Hello, everyone. Good evening. Sorry for the delay. Okay. I saw some messages in the chat and then it suddenly disappeared for me. I don't know what happened. Some weird things are going on with Zoom today. I was in a Zoom meeting today and it dropped for almost like for it used to, it was dropping off for every 5 minutes, and it was a very important meeting. I was there with some client and then this thing happened. I did not turn on the global chat. I guess it's is it? Is the global chat turned off? Let me see. Oh, so I have switched it back to everyone. Okay, but I should be still able to see. Okay. Anyways, Zoom is not acting, not behaving in the correct way it should be. Okay. Anyways, let's start. Okay, so let me just share the screen. Hello, everyone. Good evening. Okay, so how was the weekend? I hope it was good. Right, this weekend, this was like, I guess this was only one of those weekends where you would where you did not have like your weekly contest. You did not have any module test exams, right? So I guess it was good, right? Chalo, let's start on a good note, I guess. So we have completed everything on nested loops, everything. Okay, now just a quick go through on the nested loop things. Do you have any doubts that's remaining? I guess I covered everything. Only one question I gave you to solve, right? Which was diamond pattern. Apart from this, all the other questions we covered. Anything that's there, doubt, apart from diamond pattern? Or is diamond, if anyone having diamond pattern as doubt, or you solved it? Modern for loop for each type of loop. So for each type of loop, now we will not see that. You will learn that. Don't worry, we'll still do that. But now we will for now we are going to stick to this basic loop. Okay. Firstly, let's try to understand this imperative way, and then we'll understand that declarative way of programming. Okay, I'll explain diamond pattern. Chalo, no, don't worry. I'll explain the diamond pattern. Let's quickly go through functions and arrays, and at the end today we'll cover diamond pattern. Okay. Okay, so let's start with functions. So for functions, I need a plain board. I can't start it over here. Do we need arrays for Pascal triangle? Yes, for Pascal triangle, you need an array, right? For Pascal triangle, you need one way to store those numbers without, otherwise we won't be able to calculate the next row. Yes, so you need one array. Okay. Let's quickly see what functions are. Okay. Okay, so let's go through. All right. So basically, what we have is till now we have learned data types, we have learned variables, we have learned to build logic, we have learned how to write basic code on loops and nested loops, how to print patterns, how to get some work done like finding prime, checking Armstrong, and so on. Okay. So now what's remaining? What is functions? Why do we need it? Okay. So function basically solves one simple problem. Okay. So what is a function? Function is a small code. So let's see function. So function is a small code that does some small work. Okay. So function is basically a small code that does some small piece of work. Now, what is this small code and what is this small piece of work it does? Okay. So let me firstly write down the syntax. So for now, I'll tell you just ignore these two words. Okay, just assume that we'll write these two words in front of every functions. Okay, as it is. Will not change this. We'll write it as it is. Okay. Now for now, just ignore them. You will understand them in very depth. What is public, what is static when you learn about this concept. We don't need them for now, so now you can ignore it. Okay. Then similar to like loops, similar to like conditions, we have different parts in functions. So a function has 4 different parts majorly. The first thing is return type. Then we have a function name. Okay. Then we have list of arguments. Or let's say parameters. So we call the same thing as list of arguments or parameters. Now you call it as arguments or parameters, it means the same thing. Okay. And then finally, the body of the function. Okay. So this is how a function looks like. The function has four things, majorly four parts: return type, function name, list of argument or parameters, and body of the function. Okay. So now what are these four parts specifically? Let me just give you an example to explain it better. So let's say we want to write a function. So this is a small code that does a small work. So let's say our small work that we want to do is to find out the sum. Okay. Okay. So let's mark it as void. So what does void mean? So void means that function does not return anything. Okay. No return. Void means no value or nothing. Emptiness. Yes. There's a song with the name emptiness. I guess I got that term. It stuck to me, right? Okay, so it means no value. It means emptiness or absence of any value, right? Okay, so we start with public static void. Void means we don't return anything. I'll explain you what are the other things in between, right? What are the other things in between? Okay, is there any noise? Sorry. Yeah. And then let's give the name of the function as sum. What does this function do? This function takes up two things. One is int a and int b, and it finds out the sum of it. Now let me explain you this. So what is function name? Function name is any name that you can give to the function until unless it follows the variable naming rules. That we saw a list of 6-7 rules that we need to follow while naming variable. It should be starting with an alphabet. It should not. It can contain any combination of alphabet, digits, or special characters. It cannot contain any other special character apart from underscore. It can have it can be of any length, right? It cannot be a keyword, right? You cannot use a keyword as a function name. So all those same rules are applicable over here as well for the function name. Okay, so you can use the same rules to giving name to your functions. Okay. And then this list of argument is nothing but a comma separated variables along with their data type. So data type and their variable, data type and their variable. This is a list of comma separated variables that we have. Okay. 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 So this is nothing but a comma separated variables that we have, which we are going to use in our functions. Okay. So now let's say what we want to do in this function sum. So we want to find out the sum. So let's say s is equal to nothing but a plus b, and we can print this over here. System.out.println. Yes. So what does this function do? This function takes two numbers, find out the sum, and prints it. Okay. So this part of the function where we write what a function is and what it does is known as the definition of the function. Okay. So this part of the function is known as definition of the function. Okay. And this part where we are basically calling in the function, this is known as function call. Okay. So how do we call a function? We call a function by passing two values, right? Okay. Now, which part is the definition? This entire thing is the definition of the function. This entire thing is the definition of the function. Okay. And this part where we are calling the function is known as the function call. So what it does is basically see. So what happens is our code, whenever we'll run, which starts from running here. Okay, no matter what, whatever order, whatever functions we have declared, it will always start running from this default thing, which is known as public static void main. I'll explain this part as well just in a while. So it will always start from here. Okay, for now I'll assume that. So what it will see, the first thing it is seeing is sum 1020. So what it is doing, it is calling this function where we are giving two values to a and b, which is it's finding out its sum and it's printing it. So now if I run this, what you would see is you would see the result 30. So now one very valid and simple question would come to you Mind is, sir, actually we can, instead of doing so much of work, I could have simply done system.out.println a plus b, right? 10 plus 20, right? It would have still worked and I would have still seen the result 30. Why to do so much of work to get a small thing done, right? Why will I write so much code? Why will I worry about what is function, what it does, and so on, so things? Yes, the argument is correct. We'll not be using functions to write this. But what if we can write a logic instead of writing just finding out the sum? What if we can write a logic which can actually tell me whether a number is prime or not? Will that be interesting? If I write a logic and it tells me whether a number is prime or not, and I can just call it once for every number, and I can check whether a number is prime or not. I don't need to check for every number again and again and again, or I don't need to write it inside a loop to check it. Or if I want it in 3 different or 5 different parts of the logic, so I can use that function. I can use it to find out a factorial. I can use it to check whether a number is prime or not, and so on and so forth. So I can use it for other things, and for those things we'll use function. So function basically is this small code which is doing some small work by taking our inputs. So we give some inputs to the function that this is the number for which you need to find out the sum. This is the number which you need to check whether it is prime or not. And it will just check it. It will either print it. If we have marked it as void, we can print it, or it can give us the result as well. Okay. So this is a non-returning function. So it is basically to reduce the code redundancy. The function's main objective is to reduce the code redundancy and to ensure better readability. See, so now if we have like this function, so and you see this function is named as sum, and there is something that I'm doing over here. So let's say you always start running your code from void main. You don't need to worry about there are 100 or 1000 of functions. So you'll always start running your code from main. Now you see a function sum. So okay, you'll automatically get the idea. Okay, this function is doing nothing but finding out the sum of two numbers. Okay, let's proceed forward. So what else that is doing? So you don't need to check of how this is finding out the sum. Okay. Same way, let's say this is finding out the prime. So you can assume, okay, this function is finding out the prime. Tomorrow, if you need to change the prime logic and you have written 10 in 10 different places, you have called the function prime. Okay. You have called the function prime 10 different places and 10 different times. If you would have written the logic in 10 different places, what you need to do? You need to change it at 10 different places to ensure that all the codes are updated. But now, what you need to do is, since your prime is just a single function, you need to change the logic here, right? So we just follow a simple principle while writing code, that we don't need to repeat code, right? We need to write one thing once and it can be used again and again, right? We don't repeat code, we write it once and it can be used again and again, and this is done by means of function. Right. So once we write a function to do a piece of work, we can just call it and get our work done instead of writing that code ourselves again and again. Okay. And it also saves your time. So for example, let's say, I'll give a simple example. For example, let's say you want to add a video player into your site. Okay. Let's say you're creating a very good website. You want to have a video player, okay, where your video plays. So one approach is you can go and sit out to write a code that, okay, this is how my pause button will work. This is how my play button will work. This is how my user can change the quality of the video. This is how user can forward. This is how user can do a backward rewind, or so on every logic that you need to write, right? So there is so many things that's there in the YouTube. There is how user can see subtitles, how user can switch a language, how user can, let's say, add a, let's say, play the next video, play the previous video, increase the volume, decrease the volume, increase the brightness, decrease the brightness. So many things that there in a single video player. Now, either you choose to write all this code yourself. Okay. One way is you can always write this code yourself, which will take time. Other way is you just use YouTube's video player. Everyone is used to playing video on YouTube's video player. That you would see it often used in a lot of places. Right? Even our AccuJob site uses the YouTube player, I guess. We were earlier using it for a long time, I guess. Now also we use it. So let me just check. I guess it's definitely the YouTube one that we use. So this is similar. No, this is the Vimeo one, right? See, so it has also mentioned that this is coming from a Vimeo, which is a video player that we are using, right? So someone has written the code. Why to write it again, right? There is no point of inventing the bit. So we can use someone else's code, right? Now it's Vimeo. So we are using someone else's code. Whatever code we may write, that might be used by someone else as well. So it reduces your burden while creating the software. And if you write your logic, right, within the code as well. So within the code, if you write some logic to find out prime, other developer, let's say tomorrow I'm writing some logic, so I'll just call prime 20. I don't need to write this entire logic and my code development will be faster. Understood the point of having functions, why it's there. So I can proceed further to explain you a little bit depth about it. Okay. How can you create functions? Okay, there are so many hundreds of applications of it. You can use someone else's code, you can write code that can be reused again. If you want to change a logic, you just need to change in one place, and all the other places it will automatically get updated, right? You don't need to change it 100 of places, right? Okay. Okay, so let's see now. So this is one type of function. Now, is there any other type of function? Is there any other way we can find out the sum? So I guess there were a few questions in the chat. What is static? So for now, like that's the oops concept. For now, we'll skip that, right? We'll come back to that. If you don't call the function in the main, so if you don't call, nothing is going to happen, right? If you don't call, nothing is going to run because this code runs from main. Okay? The only thing that runs is everything that I've written inside this bracket. If you don't call this function, nothing is going to happen. See, no output. So simply defining a function does not ensure that we'll get this result, but we have to call that function as well to get the result. Okay. So if we just define the function, we'll never get the result. If we call it, then only the function will run. Okay. Okay. Understood? Okay. Can we? So functions are known as methods, right? So I'll like remove a confusion. So functions are nothing but methods. Okay. Functions are only known as methods. There is another term that is methods that you have attached to functions. Okay. So methods is nothing but a term for functions itself. Okay. So all the functions that we defined in Java is nothing but methods. Okay. So that's just a name that we have given to it, nothing much. Okay. So let's see what else we can do with this sum function. So instead of like printing the value, let's say we want to return the value. So we can even return the value by taking two arguments, and we can mark this return type as integer. Now, okay, how did I like arrive at why will the return type be integer? It could have been any data type. So since we are finding out the sum of two integer values, I know that the sum of these two values is definitely going to be integer. So that's why I took it as integer. Let's say I would have found out like I was finding out sum of two decimal numbers. So I would think of a return type like double. So depending on the type of value you are returning from the function, we'll pick the return type. So here, what is the value that we are finding out? So the value that we are finding out is integer. So the return type is also integer. And we can just write a return S. Now what this would do, this would return that value. So this was good. We were printing it inside the function. Why do we need a return type? Return value, we can return that value and we can store it in some other variable and we can print it. Yes, the return type can differ from the function parameter. It has nothing to do with the parameters of function. Okay. So now what is happening? See, now when we are running the main function, sorry, there it is. I have declared the sum 2 times. So let's call it as sum2. Okay. So see, the same variable naming rules, right? There cannot be two variables with the same name in the same scope. Okay. See, 30. Now you can change this into any type, whatever you want. It just has to match the value that you are returning. Okay. If it is matching the value with the value it's returning, it's fine. Okay. Now what is happening? We are running this. It's calling this function. It's going here. A is getting the value 10. B is getting the value 20. We are getting two values, 10 plus 20, 30. We are returning the value 30. Now when we come here, we get the value 30 in this variable S. And then we display it. So we see the values. Okay. Now, one simple question. Can the function return multiple values? What if I want to return multiple values? The function cannot return multiple values. The function can return only one single value. There cannot be multiple values. So for instance, what will happen if I write multiple return statements? Sorry. So what if the function returns multiple statements? What is going to happen? So in case your function returns multiple statements, see, it is going to tell you error that this is an unreachable statement. We cannot return this, right? Can we join them by comma, comma? Can I return multiple values like this? No, this is also not allowed. You cannot return multiple values even by separating with comma. See, expected a semicolon, we did not get. So no matter how, like whatever you do, there is no syntax of returning multiple values. In case you want to return multiple values, will there be never a scenario? There might be scenarios where you might want to return multiple values. What you will do in that case, right? So in that case, you can use something like arrays, which we are going to study at the next topic, right? So you can return arrays, but not a single value can be like not multiple values can be returned. Okay? Array would be a single value, but it can have a lot of values within itself. Mention the return. I'll come to that part, sure. I'll just come to that part. What would happen if return is there inside conditions? Yes. Now, understood this part, what is return? Okay, so now you can see both the functions clearly, right? So there is one type of function which does not return any value, right? Which is like, okay. So now we can return like one type of function which does not return any value and we are fine with it, right? It just prints or gets the result. Other function which returns the value, we print it. So why do we like, why will we do this, right? It was better printing it itself. But every time when we are calling a function, we would not want to print the result, right? We might want to use it, just use it in our code to do some other work. So for example, like the day before yesterday or yesterday, I guess we solved one question where we are doing a lot of work. So for example, we are finding out the digits of a number, the number rotation problem, right? We are finding out the digits of a number. We were trying to rotate it. And then we wrote, like, I guess we wrote 2-3 times to find out the digits of a number, logic again and again to count the digits of a number. Instead, we could have written a function that could count the digits of number and it could have returned us the digit. We could have stored it. Now, every time we pass it a new number, it will just count and return the digit to us. We don't need to write that logic again and again, right? That would have been simpler, right? That would have made our a job little bit easier, right? Same way, if I have to find out how many leading zeros are there, trailing zeros are there, we would have written it in a function if we are doing that work again and again, right? Okay. So yes, so there we don't want to print it, but we actually wanted the value that it is returning. So in that case, we would want to define a function which returns the value instead of just printing it always. Okay. So that's it, right? So these are the two kinds of functions that we have. Now, what are the okay? So this is the basics about functions. What is functions? What how we write functions? How we call functions? Okay, understood this? If the return statement is the return statement last statement in the function? Yes, it is generally the last statement, but yeah, there can be ways that it like okay, I'll show you some other variations of it. Yes, but it is generally always the last statement. Anything after return will not never run, right? If you return any other data type like float, double, or something, so let's say we create this SS double. So sum of two integer can be stored into double, and if you are returning S, it is marked as integer. Will it work? No. So if I try to run this, it will show me an error that this function, see, this function is lossy conversion if we are returning a double and it is expecting an integer value there, right? So if I change it to double, now it would be fine, but here I need to also change it to double. So you can return any type, right? Until unless if it's valid, all the operations that you are doing inside function is valid and the return type is matching the return value, right? So it's fine. If the either you can do explicit typecasting to match it, or if the return type is anyways matching it, then it's fine. Okay. If return type is double and your returning value is int, that is okay, right? Because integer can be converted to double. So here also the same logic of implicit typecasting works. So for example, here return is double, but I'm returning integer. So implicit typecasting, right? Integer to double is an implicit conversion, right? So, but here if I take this as integer, then it is going to be a problem because this is going to return double. I am taking integer. Now it will tell me error. Why? Because integer to double is implicit. There is no problem there. But see, here there is a problem in the call. It is telling that this is returning double and I am trying to store it in integer. The error is here, not here. Okay. But if I take it as double here, then it will not show any issues. Integer to double is an implicit conversion. Same logic, right? Implicit conversion, Java will do it for you. Explicit conversion, you have to do it by typecasting or explicit type conversion. Okay. Okay, you can explicitly typecast it, no problem, right? So for example, here if you receive it anything, so you can typecast it as a normal variable, right? Like you typecast and you convert it into integer and store it in integer variable. That's fine. Right? If you typecast it, that's fine. Okay. Yes, someone's trying to say something. Any doubts? Anything? Okay. Clear this part? Okay. So we have functions, we can return values, you can return if it is implicit conversion, it will automatically do, right? As parameter sum to our end. So why we need to typecast? Because the return type has nothing to do with the parameters. Okay, first of all, return type and parameters has nothing to do with it. So for example, if I mention the return return type as double, so the return value that this function is going to give is double. Okay. Even if we are returning integer, integer will implicitly get converted to double. So the function's return value is going to be double anyways. Okay. The function is going to return double, right? No matter what. Now, since the function is returning a double value, right, and we are storing it in integer s, we are going to get error. So that's why we need to typecast.
Sir, but before this it was a integer, no? So why we need to typecast at that time?
Now, if it is returning integer, then you don't need to typecast, right? So let me show you this, right? If it is returning integer, then you don't need to typecast. I can run this. There is no issues. It's fine, right? But if it is returning, see, now it's fine. There is no problem. But if it is returning not integer, but if it is returning double, then there is problem, right? Because a function cannot return, this cannot be stored in integer. Now there was issue.
Okay, sir.
Understood, everyone? Having public static int A and B and public static int B and P and long B are this. No, see, okay, are they same or both are having common name but different parameters? See, so name is like variable name that you are giving. So I'll come to this naming, right? I'll just come to this naming. The names are like variable names that you are giving. So you can give them any names unless they don't match with each other. For example, can I give two variables with the name B over here and I can sum B? No, was this allowed in any scope? Or this was violating the variable naming rule. See, B is already defined in the method something. So same way, like, can you create two variables with the same name inside a for loop? Can you create two variables with the same name inside a if condition? Can you create two variables with the same name inside any block? Any block, right? You cannot do it, right? Inside any block, you're not allowed to create two variables with same name. Now, this part, the definition part, is also part of the function block. So you cannot create two variables with same name over here. Okay. Understood? So it will follow the same rule. Clear? Yes, no? Doubts? Sure. Okay, now let's understand the interesting stuff. So this was basic of function, right? So this is like very basic. You would have studied this part in the pre-course as well. You would have seen this. Acha, was like call by value, call by reference, this thing covered in pre-course? Yes, no?
No. There was some, I'm so sorry to interrupt. There was some lag in my system. So here when we will be returning this S, meanwhile we'll be printing also like in the main function.
So see, when the function returns, right? The function return kar raha, right? So we are not printing this value. So we are expecting that we'll get a value when we are calling this function. Now that value we can either store in a variable or we can print directly. So here what we are doing is we are storing it in a variable and we are printing that variable. Okay.
Okay, so we can do it right here also, no? Before return statement, and S equals to A plus B.
So that's like what we are doing over here when the function is void. So like there is a different use. For example, let's say in void function doesn't return anything, prints it there. But let's say you don't want to print the value. You want to use it, like for example, you just want to count the digits and you want to do some calculation later. So you don't want to just print it. You want the number, right? What is the count of digits? If I am giving a number to that. So so in that situations, we would want the value in return instead of printing it. Okay.
Okay, sir. Thank you.
Okay. So everyone, this is for everyone. See, I see a lot of you are very hesitant about asking doubts. I don't know why. Okay. See, you are a very small batch for me, right? 60 students, and we generally have this pioneer batch as very small, so that we can take up your doubts personally, right? If you have any doubts, feel free to speak, feel free to ask. Okay. That's why this batch size is small, right? When the batch size is like 500, 600, it becomes problematic for me to take doubts as well. And if students speak, there is like so many doubts I cannot address. But now batch size is small, I can definitely address them, right? So don't hesitate. You can ask your doubts, right? In pre-course, there was like a lot of audience. There are more than 2,000 people, and it is like literally impossible to take doubts there. But here you can take, sure. Okay. So the clear differentiation that value passed are arguments, and variables that receive values are parameter. When it comes to main method, is called argument instead of parameter. So no. Argument and parameter means the same thing. Call by value, call by reference. I'll come to that part. That is different. Okay. Chalo. A little bit about public static. So like public static, 2 words would take 1 hour to explain, right? I cannot explain these 2 words without explaining what a class is, what an object is, right? Now, I don't want to go in that direction for now. Let's understand that we just need to write these 2 words. Don't worry, you're going to understand it in very much detail. Not a very big concept, just that there's a lot of things to know before I can explain this, right? Why is public, what are the other types it can be, what static is. So for that, I need to give you idea what memory is, what an object is. So all those things will need some time. Okay, just a second. So would it change anything if I don't write public in function? So public won't change for now, right? Even if you don't write public, it is not going to be a problem. But if you don't write static, you are going to see an error. Okay. So public is not going to show you errors, right? Public is going to work fine. But if you remove the word static, it is going to show you error that you are trying to call a non-static function inside a static function. Say non-static method sum2 cannot be referenced inside a static construct. So this is the error that you will get. Okay. So public won't throw you error for now at least. So in Java, the default one is, I guess, public. No, yes, I guess it is public. In C++, it is private. In JavaScript, there is no default specifier, right? So you can just Google up, right? I guess I recall it is public. Okay, I don't write code in Java. That's why I'm a little bit hazy over here. Default specifier is default, I know, but that default specifier has a behavior, right? It will have a behavior similar to either public, private, or protected. It would match exactly one of these 3. And I guess it matches with public one. Okay. Yes. So let me explain you this. What if I write in place of void and I don't return anything? So it is going to be an error, right? So if you write a return type and you don't return anything, then that's a definitely error, right? Because it is expecting something in return and we are not. See, missing return statement. So if you write anything apart from void as a return type, then you need to return a value of that particular type. If you don't return it, you'll see missing return statement, which is the error that the function throws or Java throws. Okay, clear? Now let me give you some idea about what this function is actually and how it runs, right? Can we return values to a private class or method? Yes, you can return. So private, public, protected, that does not cause any difference in return. That causes difference in like inheritance and other stuffs. Okay, so let's come back to here. So what this function is and how it works actually, let me just show you. Oh shit. No. Okay, I got the issue. So I don't have a pen now. That's why I was feeling there is something missing in Zoom today and I don't have the option to write something. So this is the Zoom problem I see, right? Which is like the annotation mix skips. Okay, let's try to go to whiteboard then. How to typecast in returning? You can just typecast it, right? Convert it to whatever data type you want, right? So like, for example, here, this is a variable name. Just typecast it to whatever you want. If it is possible, it will type. If you want to typecast it to double, you can do it. Okay. Now the return value will be double. Is the function expecting a double return? No, it is expecting integer, right? So you can typecast it here. Like any variable you typecast, you can use it.
Sir, will it throw some error? Because here at the time of function, like when we were making function, we had written int no and
This
we are writing double.
This is error. This is error. So this is error. You can typecast it, but this is error because you can't store a double into integer. See? Now, if you just convert this into double as well, then it is correct. Right?
Then here also we don't have to convert. No, it will all like automatically throw double value.
Automatically convert. But for example, consider a scenario where you have, like, for example, this function is expecting integer, and let's say we found out the sum is double. Okay, we have some double value which we got and we want to return it. So we can typecast it to integer, right? Now this won't throw error. Now this is fine. Like we are converting a double to integer, which should be fine. Okay. Okay, I removed the call, but okay, let me do this. No, I use a digital pen, right? It's impossible to draw with mouse. Yes, now it's fine. Integer, which is fine, right?
So there is no use of writing double here, no, because it will not throw the value double itself. If we have converted at the end integer and prior the function was also throwing integer, then what's the use of writing this double s? It might have.
So, this is like I'm just showing you one example.
Okay,
Right?
thank you. I got it. Got it.
So basically, you if you need, you can convert it at the return point. But if you don't need, you don't need to convert it, right? So for example, here we know that some values are integer, some is going to be integer, some cannot be double, right? But if you have a value which is double and you function expects integer, can we typecast it? Yes, we can. Okay.
Okay, sir.
Okay, see, so now let's come to a little bit about depth of functions. So let's say we write a function function. I'm writing it in a smaller way. Let's say write it as integer function function, which takes two values. So how does this function work? What is the entire logic behind it? So we have another thing known as void main. Okay. So this is our call as the main function. This is where our logic of our code, right? This is where our logic of code starts executing or running. Okay. So what is this? I don't even have the eraser. Okay, so let's clear it. Okay, so let's have some main function. Okay, so there is some logic that we have written over here. Now we are just what we are doing is we are calling a function. Let's say we have written some logic and then we are calling the function fun, passing two values. Now what exactly happens to this call? So this is we call as function call. We're just calling the function. This is where the definition is. When we call the function, what Java does is, let's say there are 10 lines above this function, 10 lines. And then we have fun call, which is 1020, and there are 10 lines below it. Okay. So what Java will do, it will run this line by line, like we already know. So it will run this line by line. So it will run the first 10 lines. It will see, okay, there is a fun 2020. It will stop over here. That will say, okay, main function, I'll run you, but wait for a while, right? Let me check what this fun function has to do. Okay. So let's for simplicity assume that this is void. Okay, not returning anything. Okay, so fun is void. Let's say we have just made a call to it. So what it would do is it will stop the like flow over here and it will say, let's go to fun. Now it is in a different place altogether. That's a complete different place. It doesn't, there is a different scope. We can create variables in this scope. We can write a complete logic. It can be like a very complicated logic having a lot of parameters that you're passing. You can write a entire loop. You can write an entire if else condition. You can create arrays and all the other things that you have, right? Whatever you can do inside the main function, you can do over here. Just that you have two initial values that you got, and what will happen with this initial value? So it will create two memory spaces with the name A, two variables with the name A and B. What are values you are passing? So it will store the first value in A and second value in B, 20. Okay. Now I stored these two values. Okay. Two values it got. It will run the entire function as whatever logic you have written over here, assuming that it has two variables named A and B and which has two values that is given to it by the function call. The function call gave it two values. It is using it. It will run this entire logic, and let's say at the end, whatever you are doing and you are printing some value, it will print it. It will do its work, and then when this function will actually complete, जब ये function complete होगा, when it will actually complete, you will come back to here and will start running the code from the line where you left off. So you did this call, you left off from here. Now it will come back and start running the code from here. Okay. So, okay, let me show you this. Now let me, can we give only one value? Where in the function call over here? No, you can give as many values in the list of arguments. You can give as many values as you want. The return will have only one value. Okay. So let's check over there. Let's check the example of the first function call. Okay. So,
sir, sorry to interrupt you, but I was asking if I declare two parameters in the function and I just give one value, so will it work?
No, it is error. So there is an error over here. It works in dynamically typed language, but in Java is a static type language, so it will give you error. Okay.
So okay, sir.
You cannot find symbol B. Okay, let's say we are not even using B. Okay. Let's say we remove the definition of B, so it will give a okay. We have to remove the call as well. So let's say now just do this. it will show us an error that this is calling something which is not there. Sum in class method cannot be applied to the given types. So it is required int. We found integer, which is not. And what is the difference it's telling? Actual and formal argument differs in length. I'll come to this. What is actual and formal argument? You'll understand this, but yeah, we cannot call it. Okay. No. Okay. Initialize be inside the class. I know all the questions that you're getting is the parts that I have to cover today. Okay. Yes. See, so now let's say I call this function, and just before the call, I write a statement system.out.println. Then I write it as before call. Okay. Before call. So what is going to happen? It's going to run first. We are going to see before call, and then let's say after the call, we call the function, and then we print it after call. Okay, and run this. Now, what is going to happen is firstly it's going to print before call, then it's going to call the function and it's going to tell, okay, wait a minute, let me come back and complete this function. It will give two values to a and b, which is 10 and 20 that we are passing. It will run this function, it will complete it, it will get the value, print the value 30, and then at the end, after it's done, it will come back, it will run this line, which will print after call. Okay, understood this? How a function call runs. So whatever values you are passing, those variables that will be created only for this function. Once the function completes, when this block of code is done, we cannot use this variable. These variables are not there. This variable is a different block, so you can use the same name. So for example, if you already have a variable with the name A over here, can I again use the variable A over here? Yes, you can, because it is a different block. Right. So when I gave this rule that there cannot be two variables with the same name, I also mentioned it that within the same scope, right? There cannot be two variables with the same name in the same scope, but they can be within different scopes. And this is a different scope. This is a different scope than the main scope. So there can be two variables with the same name. Okay, no problem in that. Okay, understood this part? So each function has their own set of like space where they can create variables. They use it. When the function call completes, the variable dies. Okay. Our code always starts running from this main function. Wherever we start, it will always start running from the main function, and it will run it line by line. And wherever it will see functions, it will stop, pause a while. It will go run this function, complete it, and then come back and start from the next line. Okay. And it runs in the same way. Even if there are multiple function calls, let's say after fun, I have called a sum function over here. Okay. So whenever it will see a sum function, let's say 20, 30, I pass three values to sum. So it will run till here, and then when it will see sum, okay, let me go to call the sum function. I'll run the sum function, then I'll come back. Okay. If it is returning a value, it will just get its value. We would have stored it in some variable. We'll get it. The value will store it. If we are using it somewhere, we'll have this values. It will have the value in this variable. Whatever this function is returning, it would be returning something. So the compiler converts it in the same way. So compiler, yes, converts it in the same way. For the compiler, everything is a single block of code, right? So it doesn't have this different. So compiler will convert every line instruction line by line into 0 and 1. Okay, whenever it sees a function, let's say it's a function over here, it will just replace it with its definition. So whatever logic is there, it will just replace it off with whatever we are doing in this function. Okay. So the compiler does this. Okay, you can think it of like doing this. Is it possible to call function inside another function? Yes, you can call a function inside another function as well. So main is also a function. Okay. Now let me show you how main is a function. So the thing that we are using here is main, right? So main is also a function. Okay. Now how is main a function? So see, is it matching all the parameter checks that I gave you for functions? Let's see. So function should have four parts to it. Return type, function name, list of arguments and parameters, and body of function. Does it have? So it has a return type void. Yes, I know it does. We does not return anything. We have never return something. So its return type is void. Okay. Is it main? Yes. We have given some valid function name. It is not a keyword. So it is a valid name that we can give to our functions. What is this? This is an array of strings. Okay. You might have seen array like this. Is this a normal variable? Yes, it is a normal string variable. Okay, so it takes a string array as argument. Okay, you can give it any name, right? You can give it string A, Z, or whatever you want, right? So everything works, right? So this is just a normal variable that we are given. This is an array. We're just going to learn about array, so this will also be clear. What is an array? Okay, so this is a normal array variable of string type. Okay, That's it. And then it has a valid body that we are running. But where are we giving parents in the main? So actually, I'll give you some idea about, and you might get this in an interview question, might not. It might be a brief idea about Java. So when Java evolved, right? So we did not have this black kind of interfaces to run this, right? So there was like some. So what Java expected was, whenever you're running a code, you should give all the inputs initially beforehand. You give all the inputs, and then it will run the code, right? Initially, you give all the input. It will take it as integer. Sorry, it will take it as string, and then you convert it to whatever type you want. So let's say you want 5 inputs from user to run the code. So you give all the inputs beforehand while running the code, and this as an array of string, and then you can use it. So this is a valid array which you can use it inside your code as well. Okay. So and that's why this was there, string args in the main function, where we gave all the inputs as string array. Later we evolved and we thought, okay, we can have a black console where user can give inputs while running the code itself, and we can, based on those input, give the outputs. We can take more inputs, whatever we want to do. Okay. Again and again from main, so again, just little bit improve it. It is a set of logic that we write, right? So that it can be reused again, right? Not specifically for the main function. It can be called from any other function as well. Where can but where we are initializing the main function, where we are calling it. So main function call happens by the compiler. Okay, main function call happens by the compiler. We are not calling the main function. So compiler calls only one function, which is the main function. Okay. So I'll say, okay, sir, what will happen if I remove this? I rename it. So now it will not work. See, if I run this, it will say us that there is some missing main function. Main method not found in the class main. Please define the main method as follows, which looks like this. Okay, so it says that for the okay, so this main is the name of the class, right? This is the name of the class. Will not touch that part for now. This is the name of the function, which should be following variable naming rules that we know. Okay, there can be only one main function that we have. At least for now, we'll stick to that. Okay, so this main function is basically the function that is called by Java to run our code, and this is where the code running starts. Okay. No, we cannot replace it. In case you replace it, you'll get the same error that the main function definition is missing, right? So the main function definition has to be the same. Okay, missing return statement. See, it is missing return statement. Now you can return some value, which you won't require, right? So you can write this integer main return 0, which I guess doesn't do anything. Okay. Main method must return a value of type void in the class main. Please refer to. So you cannot fix this. This has to be void type. Okay, void main. This has to be the type of the function. No, it does not depend on the class name. This always has to be the name as main. Okay, so this does not depend on the class name. The name of the function is always main, irrespective if you change the class name. That's also fine. But the name of the function is going to be main. Okay. Can I give any arguments now to main function, and how can we do that if we want to? So we can give arguments to the main function that is not supported. Like for example, in this is a very small kind of compiler. You have to install some heavy version compiler like BlueJ, where you get the option. Let's say there is a very good Java compiler which is known as BlueJ. You can use that, or you can use IntelliJ platforms where Java is supported. Right? So there, when you run the program, it would give you a small pop-up and ask you whether you want to give some inputs. Now, if you give any input as an array of strings, that will go to the string argument. Okay. So yeah. But right now we don't have control because this is a limited compiler, right? This doesn't give you a control to pass input. If in case it does, I have not explored it that much. I don't see, might be there. We can change it somewhere from settings to do it, but I don't see there is some. I don't see there is some settings like that. Yeah. So the basic version doesn't do that. So yeah. So now we can, why this is not going away. Oh, this is so bad. How do people code in Lightroom? Okay. Anyone who goes, oh, it's done. Okay. Anyone who codes using the light mode. So there was like this chat there. I was not seeing that done option. Yeah. Okay, understood? Clear? I'll explain the argument in detail. Okay, apart from argument, everything is clear. So argument is the value that we are passing to the function. Okay, so arguments are the values that we are passing to the function to get its work done. See, so what is the definition that I gave to function? A small code that does some small work. Now, how will this work will get done? So this will get done if we give it some value. So for example, let's say I want to find out prime. Okay, let me write one function that finds out the prime. So tell me what are the things that we need to know to find out whether a number is prime or not. The number, right? We need to know whether a number is prime or not. What thing we can return? Let's say we can return boolean, whether the number is prime or not. Okay. How many numbers do we need? We need a single number to check whether it is prime or not. That's it. Okay. So what we'll do? Yes, there can be functions without arguments as well. You can take inputs of numbers within the function as well. That is also fine. Okay. So let's say we start with 2. We go all the way up to, let's say, square root of n, math.sqrt a I plus plus. So I'll show you an interesting way of writing this. Okay. So we ran the loop from 2 to square root. If there is any number that divides this, so for example, if a percentage I double equals to 0, that means can this number be prime? This number cannot be prime, right? If there is any value that divides a, so we can simply return false. Okay. How it will work if we are returning over here directly? So when you return over, when the function hits the return statement, no matter wherever it is. So let's say this loop was still left a lot of iterations to run. It will just stop then and there and it will come out. Okay. So you can treat return like a break for functions. Okay. You cannot use break and stop the function execution, right? Break cannot stop a function execution. It can stop a loop. Okay. But when the function hits a return statement, it pauses, is completes its execution then and there. Okay, and whatever is the value that it gets in return, it returns it to wherever it is getting called. Okay. So return is like a end of the function, and whatever value you are returning, it will return it from then and there. And at the end, if we don't find any such a thing, we can return true, which means that this number is a prime number. If there is no factors of this number from this 2 to square root of a, then this is a valid prime number. So we can return true at the end. If there is any factor, we'll return false, and then there is nothing else that will run. Okay. Now, how is it working in case we are having 2 return statements? So even though we have 2 return statements, only one of them is going to run. Again, not both of them can be hit, right? So Java knows this. How? Because we have put the other return inside a if block. If I write 2 returns without having any if block, okay. So let's say this function returns a value, right? So can I return one more value over here? No, it will give you error. Why? Because you're trying to return 2 values from a function, which is not allowed. Cannot find symbol. So let me uncomment this, and uncomment this. So see, now you are returning 2 values, so it will tell this as an unreachable statement. See, this statement cannot be reached because this statement is definitely going to hit. So this statement, there is no way this statement can ever run. So that's why it is giving an error that this is an unreachable statement. But now here, look, here this statement will only run if the if condition satisfies. Java understands this, and here I would say Java is a little bit smart as compared to the other places where it is not. So it understands this, that this is inside a if block. So this might not run always. This will only run if this condition is true. So if this condition is false always, then this will never run. So we can use the last return. So anyways, one of the returns can get hit. There is one return in all the cases, right? And if this is not returning, then we'll definitely return from here. Okay. And if this is okay, understood. And if this returns, we'll never read this return part of the function. Can we define define a function into another function? Java I guess it is doable. Yes, you can have local functions as well, but I'll for now will not go to that nested function, local functions. So okay, part will not touch that part. It's possible, I guess, one way. But yeah, we won't do that now. Yes, it's possible. Yes. If condition is true, then also other return is opened. If condition is true, no. If the condition ever is true, we hit one return and the other return never hits. Okay. So if the condition is true, we hit one of the returns and the other return never hits. Okay. So let me show you. Let's try to make this call. So function system.out.println. Okay. So this function is returning a value, right? So we can even print it directly instead of doing. So print prime, whether 10 is prime or not, and let me just copy it and check for the other value. See, call it with the value 7. So one of them is prime, other is not prime. So for one of them, I'll get the value true. For other one, I'll get the value false. So the first one is getting the value false because it is not a prime number. Second one is getting a value true. It is true. So see, whatever is the return type, right? So when the function returns value, there are two ways you handle this. So one way is you store it in a variable, print the variable, use it later if you want to do something, if you want to write some logic on it, or you print it directly. So for example, what we are doing over here. So whenever this function is returning the value, what I'm doing is I'm directly printing it using println. I'm not storing it, I'm just printing it. Okay. Can we store it? Yes, we can store it in a Boolean variable. So if you want to store the result in a Boolean variable, you can store it, right? So let's call it Boolean b, and we can store it as prime 40. I will store it. How many times can I call? Infinite times. That's the entire purpose of functions, right? So we define it once, use it again and again. So just you create it once and you can use it as many times as you want. Okay, no difference in output, but you can store it. Right? If you want to print what's the value of b, you can print it. If you want to use this, now since this is a Boolean variable, you can use it as a condition of function, right? So what's the condition of a function can be? This condition can be Boolean. So let me just write this as system.out.println. If this is true, will print it is prime. Otherwise, will not print anything. Okay. So now we can do this as well. See, it doesn't print anything because this is not prime, but let's give 11, which is prime. So it will print it is prime. Okay. See. Default arguments, yes, there are strippers. We can do that. We can have default arguments at the end of our function, I guess. Yeah, that's there in all languages. It should be there in Java as well. Okay, understood this part where you can return. If you have multiple returns, you can write it, but the other returns should be such that each return should be reachable. Okay, so it doesn't matter conditionals or anything. Each return statement should be reachable in some condition, and that is most likely possible because other returns are written inside some if condition. If it is not written inside a if condition, the last return will never hit. For example, here if I write another return, the Java will throw you error that this return is never going to hit. So this is an unreachable statement. Okay, so for this you are going to get unreachable statement. Okay, understood this part. Understood return. If you have multiple returns, that's fine. Only one of them will return, not multiples. That's correct. Okay, you can have values, you can return it. Writing the definition above the main function always. So it's a general practice to write the function definition before it's called, but in Java you can write it below as well. That's not a problem. So in case you want to write it below, you can write it here as well. So that's also fine. After the main function, if you want to write it, that is also not going to tell you any errors. Okay, you can invoke it as well. Let me uncomment one of the calls. This is fine. In Java, it is not a problem. Okay, so in C++, there is a problem that you need to define it before the main function. That is not object oriented. So yeah, there is something. And you follow this approach of writing a function definition before it's called, so that let's say for example, why so this is for a better readability. So for example, whenever I see this function, I'll know that I need to look at the code above it. The definition might be above it, right? The definition won't be below it. Below it there might be 100, 1,000 or million lines of code. That's why I don't want to go through those million lines of code to search this definition. So that's why we write it at the above. Okay. Shripad, I can't. Okay, you shared the code. Okay. I guess it is there, but not in this way. Let's check, right? If we let's check how we can get default values. Okay, let me complete this part. Okay. So understood for firstly how function call happens, all these things. There is no doubts, anyone, right? Okay, so I can proceed to the next part, which is the most interesting part I'd like to show. Okay, and this was my Microsoft interview question. Okay, so consider this is like very important. Okay. Okay. So this is a very important concept known as call by value and call by reference. So first I'm going to cover call by value. When I'll cover arrays, so I'll revisit this part and explain you call by reference. Okay. So for now we'll understand this call by value. So what is call by value in a function? So every function is called by value. Okay, every function is called by value. Okay, and let me correct this. Every function is called by value for primitive data types. So for primitive data types, as in, so for integer, floats, double, boolean, okay, even strings are considered here as primitive types. So strings are also called by value. String is not called by reference. Okay, now what does this mean actually? Okay, so let me give you one example that would be easiest to understand. So let's say I write one function. Let me write it as before call. Okay, before of the call of the function, I'm doing something. Then I'm making the function call. Let's say I'm passing it. Okay, one thing. Let's say a is equals to 10, and let's take two variables. B is equals to 20. I took two variables inside this. A is 10, B is 20. I'm passing these two variables over here. Okay, and then I'm printing it after call. String is primitive. String is a primitive type, but it is a non-reference type. No, string, I guess, is not primitive. It is a reference type. So let's primitive reference. String is reference. String has a class. Integer also has a class, but int is primitive, right? In string is reference. String is not primitive. It is just it is a reference type. I can confirm that. Okay. So public static. Let's do void. It is not returning anything. Sum. Okay, I'm defining this below. Okay, it doesn't matter whether you define it below or above. Okay, just I'm for easier readability, I'm defining it below. Okay, now look what this function is doing. Okay, so I'm assigning the value of a is equals to 100. Also, let me do one thing. System.out.print inside call. Okay, before call a b, after call a b, inside call a b, Achha. Now tell me what is the final result that you are going to see in the console for this. Yes, this function is type void. Int and integer are not same. Int is a data type. Integer is a very big thing. So you can think of integer like int plus a lot of additional things, lot of additional capabilities. Okay, we are going to learn that additional capabilities. Okay, tell me the output. Tell me the result, right? So what's the order, and just write for the results and along with the values of A and B. Okay, what's the output that you'll see? Just the output. Okay, what's the exact output you'll see? I just want to think. Take a minute. I told you how the function runs. Achha, leave aside. Just tell me what you will print. What this line will print. What this line should print or will print. What do you think? Okay. After call 100, 200. So now if I run this, actually you would see this line is printing after call 1020. It's not printing 100, 200, it's printing 1020. Let me add a space in between so that you can see those numbers separated. Okay. So how this is working? See, just like revisit what I spoke about this function call, how this runs. Okay. So what I told you at that point of time, that okay. So let me repeat that part. So when I told you about this function call and I showed you this diagram, I told you that what is happening whenever you're writing two values over here, this function gets those values. It has its own scope, it has its own memory where it creates these variables, run the logic, and then comes back. Once it comes back, all these variables are done. There is no such A and B. But when this function is running, it has to not bother about any other A, B, or anything else that exists, right? And I even showed you that here, if you are having two variables, right? If you have a over here and you have a b over here, it doesn't give you any error that there are two variables with the same name. Okay, so now let's put all these things together and see how this is working. So firstly, we see this line where we are creating two variables a and b, which is having value 10 and 20. Okay, so we have two variables which is having the value 10 and 20. Okay, listen to me this for once and it will become clear. Okay, so we have two variables having the value 10 and 20. Okay, and then we firstly run this line before call and we print 10 and 20. Yes, is this part clear where we print 10 and 20 before call? Okay, यहाँ पे कोई doubt नहीं, right? We just created two variable, printed it. Now we are calling a function and we are passing these variables. Now actually when you pass variables, okay, let's say, let me explain you over here. So let's say there is a variable, let's say there is a function known as update. You pass it value a, okay, you pass it a variable a, and this is where the function is defined, update, and it takes a value int a and it does something with it. Let's say a equals to a plus 10 or whatever it does. Okay, it changes it. Now let's say a value was 5 over here. When this function was called, what happened actually was, so there was a variable with this function which is calling this function. So in our case, there was a variable with the main function. A main function has a variable. Okay, main function has its own thing which is a variable. It knows that I have a variable, its value is 5. Excuse me. When I called this function, what actually happened was this 5 was passed to this function. Now this function got the value. This function created a variable a, it got the value 5, but it stored it in that variable a that it newly created. It has no knowledge of any other a existing. That's why we call this as call by value. Whenever we are calling just by the value of the variable that we are using. Okay, so whatever variable we are using in the function call, we are just calling it by its value. We are not passing any variable that this is the variable. If you want, you can update it, you can change it. No function can change this variable. Okay, this variable cannot be changed by any other function because this belongs to the main function. Another function can change it. So whenever I pass this, I am just passing the value of a to a. Can this be two different variable names? Yes, it can be. So you can take this variable name as well different here, or it can be a different variable name in the main function as well. That is also fine. Okay, even if you have it as xy, so now it looks like two different variables. But even if you have the same names, right? So xy, this looks like a two different variable, and now you'll say, okay, sir, now it is two different variables, so it should be different. But even though if it is not two different variables, even if it is the same variable like this, you would still see. First time when I called this, we shot 10, 20, which is fine. I call this function here. I got just the values, which is 10, 20. So I'm saying before update 10, 20, which is fine. I change these two values 100, 200. Will it reflect? It will reflect within this function. Within this function has two variables, which is 10, 20, a and b, which will have the value 100 and 200. It updated it within this function. Now when I'm printing it after update, it's seeing 100, 200. Now this function call completed. I went back to the main function, and there, when I'm printing after call a and b, which a and b it is going to refer? It is going to refer its own a and b, which is having the value 10, 20, which we never updated. So this is going to print 10 and 20, which we are seeing over here. Okay, so every function, these variables belong to them. Now, whenever the update happens, it updates it in their own copy. It doesn't do anything with the other functions. So every variables within their scope, it updates their own variables. It doesn't update the variable of other scopes. Okay. And this call where we are just passing the value of the variable is known as call by value. Understood? Yes, no, I'll explain once in Hindi. Yes, I'll do it. Just let me complete once.
Yes sir, एक बार समझा दीजिए कॉल बाय रेफरेंस थोड़ा सा हिंदी में.
ठीक है. तो कॉल बाय रेफरेंस I'll come to that. ठीक, कॉल बाय वैल्यू एक बार बता दे. देखो क्या होता है कॉल बाय वैल्यू. हमने एक वेरिएबल बनाया मेन फंक्शन में, किसी भी फंक्शन में बनाया, ठीक है, मान लो. अब वहां पे हमने किसी और फंक्शन कॉल में उस वेरिएबल को पास कर दिया. ठीक है. अब यहाँ पे हमने बिफोर कॉल प्रिंट कर दिया कि इसकी वैल्यू 1020 थी, फंक्शन पे पास करा, और उसके बाद आफ्टर कॉल प्रिंट करा. ठीक है. आफ्टर कॉल पे आएंगे, बिफोर कॉल में तो 1020 रहेगा. ठीक है, एक्सपेक्टेड है, उस पर तो कुछ चेंज नहीं करा, फंक्शन पे पास करा. यहाँ पे होता क्या है कि जब भी मैंने यहाँ पे वेरिएबल पास करा है, वेरिएबल इस सम फंक्शन को ए और बी वेरिएबल के बारे में कुछ नहीं पता है कि कोई ए बी एग्जिस्ट करता है मेन फंक्शन में, उसके पास कोई एक्सेस भी नहीं है, उसको कोई मतलब भी नहीं है. वो अपना ए और बी वेरिएबल क्रिएट करेगा, वो उसका अपना वेरिएबल है. ठीक है, उसको ए मेन फंक्शन के ए बी वेरिएबल से कोई मतलब नहीं है. इसकी मेन के पास अपना ए बी वेरिएबल है, अपडेट सम जो भी है उसके पास अपना ए बी वेरिएबल है. अब यहाँ पे हमने प्रिंट करा अपडेट ए बी. सो इसके पास इनिशियल वैल्यू क्या आया था, जो मेन फंक्शन से वैल्यू पास हुई थी 1020. तो 1020 वैल्यू तो आएगी. ठीक है, वैल्यू आ रहा है इस फंक्शन से. ठीक है, हमें 1020 मिला. फिर हमने चेंज कर दिया इसको 100 200. ठीक है, हमने 100 200 में चेंज कर दिया, वैल्यू अपडेट हुई. हमने यहाँ पे चेक भी करा, वैल्यू अपडेट हुई. आफ्टर अपडेट हमें दिखा 100 200 वैल्यू अपडेट हो चुकी है. बट इसके बाद राइट, इस फंक्शन कॉल, ये फंक्शन कॉल कंप्लीट हो गया, मेन फंक्शन में गए. अब मेन फंक्शन में हम ए और बी प्रिंट कर रहे हैं. अब यहाँ पे क्या हो रहा है कि क्योंकि ये अपडेट इस फंक्शन में हुआ था जो कि मेन फंक्शन के वेरिएबल को अपडेट नहीं कर रहा, अपने वेरिएबल को कर रहा है. सो मेन फंक्शन का वेरिएबल के पास अभी भी 10 और 20 है, उसके वैल्यूज अपडेट नहीं हुए. ठीक है, तो मेन फंक्शन में जब हम प्रिंट कर रहे हैं, सो वो 1020 ही प्रिंट करेगा. और इसको कॉल बाय वैल्यू बोलते हैं कि जब भी हम फंक्शन कॉल करते हैं हम सिर्फ वैल्यू पास करते हैं, वेरिएबल का कोई रेफरेंस, वेरिएबल का कोई कॉन्टेक्स्ट ही नहीं पता होता. जो फंक्शन रन कर रहा है वो अपना वेरिएबल बनाता है और अपने हिसाब से लॉजिक रन करता है. वो मेन फंक्शन के वेरिएबल्स को अपडेट नहीं कर सकता, या फिर किसी भी फंक्शन के जो भी उसको कॉल कर रहा है उसके वेरिएबल्स को अपडेट नहीं कर सकता. Right. So call by value means the original variables remain intact irrespective of whether you are updating it in the other function. The other function doesn't know anything about the main function. I'll show you a point where you have actually done this. Okay. I guess you all have already done this, but not inside function. You know it from the block perspective. Okay. Block perspective, so you know this. How? So let me show you this. Let's say int I is equals to 1, I is less than equals to 10 I plus plus. Okay, and let's do system dot out dot println या फिर अच्छा चलो ऐसा कुछ करते I plus plus. ठीक है, I plus plus करा हमने, यहाँ पे I equals to I plus 10 कर देते हैं. Okay, so in this block I अपने वैल्यू को अपडेट करता है. What happens when I write int I equals to 1? So it creates its own variable, it updates it, it changes it. ठीक है, is until I'm using some other variable which I'm updating it, it is changing its own value, right? It is not changing any other variable's value, and this I is limited within this block. अब यहाँ पे भी ऐसे सोचो कि ठीक है, it is changing within this block. I cannot use it outside the block. It doesn't have any access to this outside the block. Outside the block, I cannot access it. I cannot update it. Within the block, I can do anything. I cannot access it. Same thing. Assume over here. यहाँ पे when I created this a and b variable, which block it belonged? It belonged to the block of this main function, right? Which starts from here and ends here. So how can I update it in some other block? Not possible, right? A variable cannot be accessed outside its block. So that rule follows over here. So this variable can no way be updated over here. This is a variable which belongs to the sum function. How can we give update to this over here? So there is no way we can give update. We can return value, store it in the variable, that we can do, but that is like returning value and re-updating it. But we cannot update these values in any way, right? So one way is like we can return one value. So let's say, for example, we can create an update function which returns value. So let's create this public static int update, and let's take int a. Okay, and what we want to do over here is we want to do, let's say a is equals to 100 and we can return it. Or let's say a is equal to a plus 10, which is more generic. Okay. So what this update function does, whatever a we pass, it increases it by 10 and returns up the new value. So what we can do is, let's say int a is equal to 5, and we can do a is equals to update a. So what will happen now? So initially it will pass this value a to here. It will get the value 5. Okay. Now it will update its value by 5. So this is a of this function. Okay. You can keep it with some other name. Let's keep it with b. Okay. So it is easier for you to understand. So the value of a got passed to this variable b, which can be of the same name if you want. So this a and this has nothing to do with each other. They are different variables. This is a variable with this block, and that a is a variable with the main block. Okay. Now here this b, I updated it by 10, so it became like whatever was the value of b, it increased it by 10, and I'm returning this b. Okay, I'm returning this b. So finally I returned this b. So and I'm storing it back in a. So a value actually got updated by 10. So but since we can return only one values, we can do it for one variable. But if you have multiple variables, then we can't do it, right? So we can't return multiple values. So this cannot be done. But if we have a single variable, we can do it. So now a got updated to 15. But if you have multiple variables that you are updating within the function, for example, over here, we cannot return multiple values. There is no way to return this multiple value, right? So we cannot have like write a comma b equals to something that cannot get updated. Right? And here also there is no, like here also it is following the same call by value, just that with return value I'm like reinitializing it. It's not like following any other thing. It is still call by value. Okay. So it returns the same value as we pass in params to function calling. It returns the same thing, but by increasing it. But if I just like remove this increasing part, so it will just return the same value, right? So if I just remove this increasing part, it is going to just return the same value. So the exchange between function call, function definition happens in forms of value. Okay. So यहाँ पे it doesn't give any variable or to this function or anything to change. It gives just the value that is there in that variable. It uses this variable's value and those things. It doesn't have anything to do with the variable or doesn't know anything about the variable. It has its own variable, does work on its variable, gives us the result. Okay. Understood? And this concept is known as call by value. So let me write it over here before this. So what is call by value? And this is very important. This is asked in interviews. Okay. So call by value. So function call, in function call, let me write it in this way. In function call, the value of the variable is passed. Okay. How is this call by value? So this is call by value, right? We are calling this function by the value. We are just passing the value of it. But the function doesn't know anything about this. So this variable that it is creating its own variable. It is just receiving the value. So here also we were just passing the value. So the call was actually happening just by value. There is nothing that it knows about the variable. Okay. Now what reference would be? Think reference would be just its opposite, where the function will know things about the variable. Where it can be in case of objects, in case of arrays, where we'll have reference. How that is going to happen, we'll learn about arrays, and then you will understand why it is reference and why these things are values. Okay. Understood? Clear? Okay. Now there is some things that I can like some technical terms that I can give you that you might get as questions. But this is the entire concepts of basic functions that you need to know for now. Okay. So you have, let me summarize everything and then I'll give you those terms. Okay. So we started with function, which is a small code that does some small work, right? We have basically 4 parts to it: return type, name of the function, list of arguments or parameters, and then the body of function. Okay. I'll give you, don't worry, I'll give you examples as well. Let's cover arrays and then I'll give you example of call by reference. Okay. I need to explain something about memory, which we'll cover in arrays, and then I'll give you example of reference. Okay. So we have return type, we have function name, we have list of arguments and parameters, and then body of function. Arguments and parameters mean the same thing. Okay? Whenever you mean argument or parameter, it means the same thing. And this is also known as arguments or parameters. So sorry, this thing that you are where you are calling the function. So whenever you are calling the function, these are also known as arguments or parameters. No matter you are using it in the function call or the function definition, it means the same thing. Okay, there is one small difference. Okay, so let me show you that. You can even interpret it from there. So let's say I have created a function sum2, and this is the sum2 wala function. Okay, I'm calling this sum2 wala function, and instead of taking 2 arguments, I just take 1 argument. It will give you one error. Yeah. So actual and formal parameters differ in length. Right. So what are these actual parameter and formal parameter? So this parameter that you are having in the function definition is known as formal parameter. This parameter is known as formal parameter. And this parameter which you are having in the function call, this is known as actual parameter. Okay. So let me write this definition somewhere so that you can remember it. Let me write it over here. So what is formal parameter? This is the parameters in function definition. And what is actual parameters? This is the parameters in function call. Okay. So the parameters that you have in the function definition, they are known as formal parameters or formal arguments, and this function call is known as actual parameters or actual arguments. Okay. Okay. Now, okay, so we have a definition of the function. We have a function call, which basically calls the function, passes some value. Even if you are writing some variable name, it will still get just the value of it. It doesn't matter whether you're writing variable name or you're writing direct values. The function will only just retrieve value. And this property of the function is, this property how the function behaves is known as call by value, where we are just passing values to the function instead of anything else. So is it no, arguments and parameters means the same thing, right? Arguments and parameters means the same thing, just that it's different way of saying it. Because the formal arguments, formal parameters means the same thing. Okay. No, string is also called by value. Okay, let me show you over here. So you can even check for string. String is a call by value. I'll come to the string implication, but you can validate it. It is call by value. Okay. Now, apart from this, there is one last technical term which is known as signature of function. What is signature of function? Okay, might get this as question. What is signature of function? So what is the signature of function? So this very first statement of the function is known as signature of function. Okay, this entire line. So not this entire line, which tells us about the return type, name of the function, and the arguments of the function. So what is the signature of function? This is the first line of function definition, which tells about the return type, function name, and arguments of function. Okay. So this is the this is known as signature of the function. Okay, got it? Understood. So this is all the definitions. You can return multiple values until so if you have a valid return, it should not throw you an error. Now in this particular example, let's say when we are checking for prime and I don't return anything. Okay, let's say I have not written anything at the end and just return over here. Okay, assuming that if it is not prime, it will return false. Okay, but see, when I run this, we get an error at, in line number 46, that missing return statement. So when you are having a return type defined in the function, you should return a value corresponding to that type. Okay, and that should be outside any condition. That what if this condition is always false, right? This condition is always false. Java doesn't know, right? This condition is going to be true or this condition is going to be false. Java will consider the worst scenario. What if this condition is always false? Right? This condition never satisfies, which can be true for if this value is a prime number. So our function won't return anything, but it should return ideally. So in that situation, so Java will throw you error that you don't have a return statement, right? So Java will initially throw you error that to give a like return value at the end. So even if you have some return inside a condition that will always be true, it will always be satisfied. So that's fine, but you have to return one value so that this error is right. Your function should return some values which is non-conditional, which it should return always, right? You can have return values inside a if else, that's fine. So for example, let's consider this function. Okay. So what if I put this inside if condition, let's say page 10, then return s. So and I run this, that will give me an error immediately, right? Missing return statement in line number 38. There should have been a return statement before the function ends. But if I put a else block, right? So Java is smart enough to know over here that in case the if doesn't run, the else will anyways run, right? So let's say else return 10. So now Java won't give me any errors if while running this, because Java knows that in case this if is false, it will anyways get a return value from the else part, right? In case the if is false, it will get a return value from the else part. This Java is smart enough to know. But if you have just the if part and you don't return anything, then it is a problem. Okay. Do we need to actually put it in the else part? No, you don't need to do it actually in else part. If you just have a if and you return at the end, so Java will see, okay, in case if satisfies, I return from here. In case if is false, I return from here. So it is not going to show you error in this situation as well. In case if satisfied, it returns the error from here. In case if doesn't, then it returns the value from here. So it is a win-win situation in both the situations. So it doesn't throw you error. Okay. So either you put something in the else or you put something at the end. No to functions, for now, no should function should have the same signature. There is one way to actually do it, which is function overloading that you'll learn in OOPS concept. So you can have same, not exactly same signature. You can have same return time function name, but list of arguments should vary. So the signature of function is unique. You cannot have two functions with the same signature, right? Like little variation in the signature should be there, and ideally it is there in the argument of the function. Okay, Java doesn't allow you to overload function based on return type. So yes. So there cannot be two functions with the exact same signature. What is signature? This very first line of the function definition, which tells you about the return type, function name, and the list of arguments. Okay, except the body, right? So basically these three parts. And there cannot be two functions with the same signature. So what if I try to create one more function with the exactly same signature? So let's say this is a sum function, and these two functions have a different body, right? But I try to create both of them as the same function. Let's say, let me mark it as void. Okay. And so let's mark it as integer. It's going integer and then let's return one value from here, int 10. Okay. And let's mark it as integer. Now these two functions have the exact matching signature. If I run this, it will give me an error. See, some int is already defined. Okay. In this line, we are getting the error. Understood? You can change the argument and you can create it. That's fine.
Ha, Papa.
Understood? So if we write only intent in the argument, does it A and B gets its value and when T? No. You need to give variable names, right? You cannot write int, comma int. You need to write variable names, right? Function definition excluding curly brackets in the first line. Excluding curly brackets in the first line. Yes, this part. These three parts basically the part having return type, function name, and arguments. Okay. This term you are going to get like very much used to when you learn about function overloading. You'll learn about a lot of things about how you can create multiple functions having same name, right? How you can vary signatures. So all those things you learn about there. So yeah, for now you just need to know that you cannot create it, right? Similar to SSO, there cannot be two variables with the same name, right? Something like that. There cannot be two functions having the same signature. Okay, clear? Understood everything about functions. So this is it. And one very important interview question, call by value. I got this in my Microsoft interview first round. So this was a very important question. This is a very important question. Okay, so you need to know this. Call by reference. I'll just explain after covering arrays. Okay, no doubts. Shall we take the dinner break? Yes. No. Sure. Quickly go back, have your dinner, come back quickly. Let's continue from here. I'll give you a 15 minutes break. Okay, hello everyone. Welcome back. Okay, I guess now functions is clear, right? So function is basically like a good to have thing in our code where we can reuse it. Right now, do we need too much of functions? No, actually. Okay. You can write your entire logic inside the main function, that would work as fine, right? Now, if everything can be written in main function, why are we learning this now? We could have learned it later. So you need to know it, right? For example, you might be given a function in the portal to solve a question. Okay, so in the assignment of functions, if you see here, so you would be given the same, you already know this problems of solving, right? So how to count the frequency of a number, how to count frequency of a digit, right? You already know this logic, you just know how to write loops to find this one. You just need to return those values. Okay, sometimes you'll be given functions to solve questions. There would be some code that you won't have in the main function, but yeah, you can remove those functions. You can write it in the logic in the main function, work as same. Okay. So let me save this as functions. We'll revisit this. Don't worry. Right. Functions. March. Okay. As so you'll revisit this after learning arrays. We'll see call by reference what it is. You'll revisit functions when you learn oops. So yeah, you'll see this again and again from here on. Let's come back to the normal thing that we were learning, which was our DAC. Okay. Okay, so we learned about functions. Now that's fine. And we were doing our basic logic. So today I'll give you an idea about arrays. I'll help you understand a little bit about arrays. Functions, I guess, so till nested loops, you have completed all the assignments. Diamond question I'll discuss today if we'll have time at the end, or we'll take it up tomorrow. Okay, depending on if we are left with time. Okay. Now here, in case of like function, these questions are very easy. You know already the things. So there is one thing, binary to decimal conversion. Now this is okay. I'll explain this one. I'll see if we get time. There is a concept of binary and decimal numbers that I'll explain for this question. Apart from this, all the other questions should be doable, right? So try all these questions today. You know about functions, you know about loops, you know everything. There is nothing different than these questions. So you should be able to solve this. Okay, try it. If you have doubts, I'm there. We'll solve it. I'll explain you arrays, and then in arrays, I'll give you some idea. So you can solve few problems here. You can try out, and remaining concepts you'll learn. Okay. Okay. So let's start with array. Okay, so what is the array? Why do we actually need it, right? So what's the problem that we are trying to solve using arrays? So let's say class and object creation in function today. So no, that would be there in oops part. So when you learn about oops, so that you'll understand about object invocation of functions. Okay, one thing I can tell you for now. Chalo, I'll tell you one small thing about functions. Okay, let me complete arrays. I'll come back and tell you or class way of calling the functions. Okay, so that I'll cover that because I guess that you might need now. But in detail, so I'll just tell you about how to call it. In the detailed explanation you'll get about in the oops concept. Okay. Okay. So till now we have good things. We have arrays, we have variables, we have data types, we have values, we have loops, we have conditionals, everything is working fine. We can write logic that runs some particular condition. We can write loops that runs a particular logic again and again. Now what is missing, right? For each loop that we are not going to cover now, to use the for loop now. For each we are going to see later. Okay. So for now, park it, right? Don't dive into for each or something. Okay. Now arrays, what is arrays, right? So what is missing here? So we know everything, what is missing? So now let's say if I give you to store the like name or of all the students that there right now in the class. So I'll say easy. So I'll create a string variable to store your name. So let's say I'll store a string student1 is equals to Ritik, right? Ritik is our first student. Then let's say student 2 is equals to Shiva, student 3 is equals to Hina, and so on. We'll keep on doing it. Now, this is like a tedious job, right? We don't want to create so many variables and then recall which variable is storing which name and so on, right? I'll write it here and I'll share this so you can have the notes as well. Previous page notes also I'll share, right? Both the pages I'll share, don't worry. I'll share the link to both of them. Okay. And I guess the community is resolved, or there is one way that I'll share it with the batch manager. You'll get it via the batch manager as well. Okay. So you'll get both of them. Okay. Now we can do it, right? Let's say Ritik, Rahul, and we can create variables and store it. Now, this is not a good way to write this names, right? Because if you want to access this name, we need to know which variable it is stored. If you want to look for a name, we don't have a very good way to check where this is stored and so on and so forth. So what we can do is we can introduce arrays. So what is arrays? Arrays is a list of value of a single data type, and that can be referenced by a single variable. Okay. Now, why did I write this single variable? So because till now we were using variables. Okay. That was also a single data type. And if we wanted to have multiple variables, we created multiple values. We created multiple variables storing them. Now we can have a single variable that can store all these values, right? A single variable that can be used to get all these values. And if it is of a single type, it can store it them as well. Okay. So how do we create array? So we have a single variable now. Instead of having so many variables that were storing these names, we have a single variable. Let's say A. How does it differ from a normal variable? So when we used to write a normal variable, I used to write just int A. Int A is a normal variable that used to store a single value, int A 10. Now int A square brackets is the array. Now it can store a list of values. So we can pass it 10, 20, 30, 40, 15, 20, and so on. Okay. So you can pass it multiple values that are comma separated and are put inside a pair of curly brackets. Now this A is basically not a single value. This is a list of value that stores given list of values under a single name. Now, how can we access this list of values? So how can we access this list of values that we just stored or that we just created? So if you want to access this list of value, we follow something known as indexing in array. So if I write A of 0, which means the first element, we want to access the first element. In arrays, the indexing starts from 0, or in strings, indexing starts from 0. In general, in Java, the indexing starts from 0. So the occurrence of first thing is always referred as zeroed index. Okay. So the first thing is always referred as the 0th index. Okay. So in Java or in any language, the indexing starts from 0. There are very few languages, I know one which is Octave, where the indexing starts from 1. Apart from that, most of the major language that you use, Java, C++, C, Python, JavaScript, everywhere the indexing starts from 0. Okay. Understood this part? So A of 0 is going to give you the first value. A of 1 is going to give you the second value. So if I write A of 1, it is going to give me 20. So we can access each values that we have put in different places of the array by means of this indexing. Okay. Now, okay, so how does this change, right? If you want to access each value, then we'll write A of 1, A of 0. But now, if you want to access all the values, you can even go through this entire array. You can even get a property of this array. So which is you can get the length of this array. Let's store it in a variable length. And you can use a.length. What this is going to give you, this gives you the length of the array. So whatever is the length of value, whatever is the number of values that is present in array, this gives you that value. Okay, so let's say array has 5, 10, 15, whatever number of values. So it will give you that value. So it has 6 values. So it is telling, okay, the array has 6 values. Okay. I can even access all the 6 values using something known as loops that we already know. So we already know loops, and we can start a loop that starts from 0. We can go till less than n, not equals to n, because the last index is going to be n minus 1. If there are 6 values in the array, okay, there are 6 values over here. The first array value has an index 0. Second one has 1, 2, 3, 4, 5. Right? So we have together as 5 values. So index 5, right? So 0 to 5. So that's where the index should go. 0 less than n, or you can write less than equals to n minus 1. So either you can write less than n or less than equals to n minus 1. Both of them are going to be fine. And we can write system.out.println, and we can print a of I. Now see, now how is this different? So earlier we were printing a single value when I was writing system.println of 0, 1, 2. Now we are printing the entire array. We are going through the entire length of the array. So we got the length is 6. We printed, okay, the length is 6. Now we are printing the entire array by going from 0 to n, which prints the all the values in the array, which is starting from index 0, 1, 2, 3, 4, 5. Okay. So for any array having n length, okay. So if the array's length is equals to n, then the index in arrays implies the index in arrays is from 0 to n minus 1. Okay, understood? Okay, so if the array's length is n, the indexes are 0 to n minus 1. We can extract any value in the array, that is 0, 1, 2, 3, 4, and so on. Okay. So I guess this part you would have studied in the pre-course. Is array.length a function? No, this is not a function. This is a property. Okay. So this is not a function. This is a property on array, or array variable or array instance. Yes, I call it as, let's call it as array instance. No, this is not an instance variable. This is a data member or a property of this particular array object that we created. Okay, now what all these terms, that is like a lot of jargon for now. What is a property? What is a data member? What is an instance? So none of these make sense anything to us right now. Okay. So let's skip this for now. Okay, let's just assume that a.length gives us the length of array. It's like a variable which stores it. Whenever we ask it, it gives us the length. Okay, it will always give us the updated length. Whatever is the length of array, it will give us that. Okay, let's think it in that way. So whenever we create array, we have the we give some values, and that is the length of this array. And this is this is going to tell me that length. Can we change the length of arrays? In Java, we cannot actually change the length of arrays. So arrays are not flexible. We cannot change the length of arrays once we have created it. Okay. So once we created the array, later we cannot change it. Okay. We cannot add new values or things. I'll come to that part. Okay. But you tell me, this is the basics. Understood this? Arrays, length, indexing of arrays, accessing each value in the array, and then printing the entire array. If there is no value in the array, will the array give 0? So let's try to run this. See, 0. No values, 0. Okay, the length is 0. We created an empty array. Can we change it? No. So what's the use of this empty array? No use. Okay. Okay. Now let's move to the interesting part. This I guess you already knew. Right. So now what's interesting over here? Now, see, there are few properties of array that you need to know. Okay, so the first property is mutable. So arrays are immutable. So arrays are immutable. Now, what does immutable mean? So basically, once you create an array, now we created an array which is storing 6 values. Okay, this array size cannot be, array's length cannot be changed. Okay. You cannot add new values to the array and say that, okay, increase your size by 1 and decrease your size. You cannot increase or decrease, right? Cannot be changed. We cannot add or remove elements from array. This we call as the elements of array. So we, each number that we have stored in the array, we call them as elements of array. Okay. So we cannot add or remove any element from the array, whatever we have stored in it. Okay. So, but we can update them. Okay. We can update them. So for example, let's say I created this array. Okay. I got the length as well. So can I update any particular value? So can I add a new value? There is no way. Okay. Can I update any value? So if let's say I want to do a of 2 is equal to 12. Can I do this? Yes, you can do it. That will update it. So let me just show you a of 2. what is A of 2? 0, 1, 2, it is 30, right? So if I print it without updating, so it will print 30. Okay. Now if I update it and I print it, so it will print 12. So you can update the values in the array. That's fine. Like that is allowed, but you cannot like change the length of array. You cannot add or remove elements in the array. That is not allowed. Okay, that cannot be done. Adding elements into the array, removing elements from the array, those things are not allowed. Those things cannot be done. Okay, understood? Okay. So what does immutability of array means? The arrays are immutable, which means the lengths cannot be changed. You cannot add or remove elements, but you can always try to like update any element. Okay. Now, what would happen if I try to access any property in the array that is not present? So, for example, when I'm trying to do system.out.println, I'm doing 1. So I'm doing 0, 1, which is 20. Okay. When I should do 2, I'll see 30, 3, 44, and 5. So A of 5 is valid index. So A of 5 will give me 20, which is this last value. Okay. But what would happen if I try to access this A of 6? So if you try to access any element that is not present in the array, you would get an array known as index out of bounds. Okay. Index 6 is out of bounds. So what is index out of bounds? So this is the error we get thrown when we try to access an array element not present in array. Okay, understood? So index out of bounds is the error that is thrown to us if we try to access any array element which is not present in the array. Okay. Clear? Understood? Yes. Okay. Now, okay, so we understood what will get error if you want to access something that's not present. If you want to change the array length or remove elements, those things we cannot do because that is not allowed. We can update a particular value because that is possible, that is feasible, so that can be done. We cannot. We can find the length of the array, that is fine. We can iterate through the entire array using for loop. Okay, these things you would have seen. Right now comes the interesting part, which is the memory of array. Now I'll take a while to discuss this in detail because this is very important. This is like your fundamentals of how memory is there in programming. Okay, so listen to this next 30 minutes very carefully. Okay, so see, do you know which part of your how many parts of space do you have in your how many parts of space do you have in your memory? So let's see this stack and heap. No, I'm not talking about that memory. What is the different kind of spaces? So you have a RAM space that is there in your machine. You have a hard disk or a secondary storage. You might have a hard disk or a SSD, right? Okay. You also might have a cache memory as well. Okay. You might have some external memory like a floppy disk or external drive or a hard disk or those kind of things, right? Okay. So now this is also the secondary storage. This is known as the primary storage. We call this as primary or the main storage. This is known as the secondary storage. Okay. Cache again has multiple layers to it, right? So if I put it in a diagram, okay, so I'll talk a little bit about this, and this is important to understand the memory that we are going to use. Okay, will give you some idea about memory. Okay, so the lowermost level is like the most largest size of memory that you have is your hard disk or the secondary storage. It can be even your SSD. Okay, then you have your RAM. And at the top, you have like a very small chunk, which is known as cache. Okay. Cache. And then at the top of this, you even have a very even smaller memory, which is known as register. Okay. So registers are very, very, very small memory. It stores a single binary number or single binary piece of information. Okay. So the size of memory that we have increases in this order, right? Size increases in this order. Okay. Okay. So our system is comprised of all these different forms of memory. So let me give you some idea about it. So hard disk or SSD, whatever you have, that is your secondary storage. Okay, that stores your data permanently. No matter if I turn off the computer, the applications that I've stored, the videos or the like files that I've saved into my system, all those things are going to remain, right? If I turn on it, it will still be present. So why? How does that happen? Because it is stored in the secondary storage, that is known as the hard disk. Okay. Then comes the RAM. So what is the responsibility of the RAM? So RAM stores all those information that we currently are using. All the application that we are currently running, anything that is currently being used. For example, right now camera is being used. Right now the microphone is used. Right now I'm using Zoom. I'm using Chrome. So all these applications are right now running and they are using space from the RAM. So any space that they need to run, they'll use it from the RAM. The RAM gives them space to run. So any application, anything that we run is loaded into the RAM and then it runs. Then we have cache, which is very small, right? Very, very small. I'll give you idea about how small cache is. So let's say your system is configured to have 1 TB hard disk, which is 1000 GB hard disk. Okay. Your RAM would be something around 8 to 16 GB, 8 GB, 4 GB or 16 GB around that. Your cache for such a system will be 2 MB. And registers will be like even in bytes. It will be like 2 bytes or something. Okay. So this is how your memory is there. So for a 1000 TB hard, like 1000 GB hard disk, 1 TB hard disk, you have around 8 to 16 GB of RAM. You have 1 to 2 MB of cache, and you have 2 bytes or 10 bytes of register. Some in order of bytes, right? Rarely it goes to kilobytes. That's also even not there, right? You have it in bytes. If you have it in kilobytes, then that's a very good system. We're having registers in kilobytes. Okay, we have even in smaller than this. Okay. Okay. Now, so we have the largest storage in hard disk. We have the smaller one in RAM. We have cache here, and then this. Now the size of this increases. We saw this. Okay, this is the size example. The speed of them increases from bottom to top. Okay. So in this where the speed increases. So the fastest one is register. Then we have cache. In cache also we have different layers, L1, L2, L3. So there are different layers of cache which are there. So okay, that's like more depth. So cache also, like you can assume them as general cache. So cache is so like little bit slower than register, but very fast than RAM and hard disk. RAM is slower than the cache, and hard disk is the slowest one that we have in our system. That if you have SSD is going to be slower than your RAM or cache, anything that we compare. Now, one simple question to all of you: think, right? Why can't we have a system that is having entirely cache memory or entirely RAM? If that is very fast, why are we using hard disk at all? Right? We can create a system with having 1000 GB RAM. Yes. Because all the data is not usable at the same time. No. The only reason is cost. The only reason is cost. I'll give you an idea. So let's say your hard disk cost is RAM is volatile, it gets fast, but we can create a similar kind of secondary storage which is in volatile. SSD, for example, which is faster, right? That is one main reason. The other reason for having a combination of this, why can't we have a so cache is also volatile, right? So why can't we have a cache altogether and replace the RAM, right? So cache would be faster than RAM, so we can have an entire cache. So the cost of all these things, you can even Google it, you can find it on Amazon, right? 1 TB hard disk cost will be approximately same with the cost of 8 GB RAM, and this will be approximately same with the cost of 2 MB cache. Okay. So this is how they are related. The cost of 2 MB cache is same as the cost of 1 TB hard disk. Okay. So that's how the cost is there. So if you have created a system having a lot amount of cache, your cost of system would go high, and it would become like really very expensive for you to run a system. For me, anyone who cannot afford this kind of systems to run it as a personal computer. So that's why we use a combination of them to get the goodness of hard disk, to get the goodness of RAM, to get the goodness of cache, and to get the goodness of register. We combine them to create a best system such that our access of these things will be fast, the cost of the entire system would be low, and we can get all the things like our information that we store is volatile, non-volatile, all these things can be also managed. Now, what is volatile, involatile information? and involatile. So basically anything that you store in hard disk is basically permanently stored. So we call it as involatile information, something that is permanently stored, hard disk or SSD or any secondary storage that you store, right? But let's say if I just turn off my system right now, my system will lose every context that's there right now. So for example, my Chrome tabs will not open when I restart it. My Zoom meeting will not start from here. It will lose its entire context. I'll have to rejoin this meeting using the link and I have to restart my Zoom. That it will not remember. It will not remember any information that my camera was turned on, my audio was getting recorded, everything. So all the things that was there, it would forget. Okay. So this thing was running using RAM. So the RAM forgets, right? So anything that is present in the RAM, if the system gets turned down, anything happens, so that information gets lost permanently. So that we call as the volatile memory. So these three are volatile and only the secondary storage is non-volatile. This is non-volatile memory or involatile memory. Okay, understood what is volatile, non-volatile memory, what is hard disk, what is RAM, what is cache, what is where the how the size of it is there in your system, how the speed increases, why is the reason of choosing this combination instead of having a single kind of memory. Understood? Yes, gives you some idea. Okay. Now quickly one question, where do you think our code would be running? Okay, volatile involatile is, so basically volatile is a memory which this in whatever you store in volatile memory that gets lost if system turns off, gets lost if system is off. Okay, this will remain permanently in system until you delete it, right? Remains permanently. So for example, all the files I have stored, all the applications I have downloaded, so that is there in the hard disk. So that will remain permanently even if I turn off the system. But the current thing that system is running is present in RAM. So anything that I run, it gets loaded from the hard disk to the RAM, computer runs it. And until it runs, it will keep it in the RAM if I close the application. So for example, if I close the Chrome browser right now, it will forget about that, what it was running in the RAM. Okay. There is an application known as Task Manager. So let me just show you task. Achha, I might guess this screen is not shared, right? Okay, let me share this. Okay. So there is an application known as Task Manager that's there in your device. Right now, here you can see what like what are applications are currently running. So these are the application that is currently running in your RAM. What are the application that is running in the background? All those things, it gives you information, right? How much amount of it memory it is consuming. So for example, Chrome is consuming 1484 like MB of RAM, right? This is the amount of memory which is it consuming from RAM, and all together out of my whatever is the size of my RAM, 64% of it is used. Okay. So if I keep on increasing like more tabs into my Chrome or opening more applications, there would be some point where my system would break. Okay, it won't be able to run these many things, so it would break. Okay, it would hang and then I'll have to restart it. We can so one reason, like most major reason to have our systems is cost, right? We can create non-volatile. So if the data is lost, we won't store it in cache kind of memory, which is volatile. We can create a cache kind of high-speed memory, which is involatile. Okay, so we can do that, and that's there in supercomputers. But like as stated, right, supercomputers costs are very high. They can store a lot of information. The read write is very fast, as for like similar to what cache and RAM is. But the cost of supercomputers goes into crores and like hundreds of crores of rupees, right? So that is like really expensive one. We can do that. It's not like it's impossible, but the major factor is cost. Okay, so that's why we generally use this combination to avoid that cost and get the better version of everything. Okay. Understood. So this gives you some idea about memory. Now the question, coming back to the question, so you have RAM where our code runs, right? Our code runs, so it will be there in this part. So I told you, right, any application, anything that runs is in the RAM. Okay. So ROM is like read-only memory. So that is like we just read from it, right? So we don't write anything. So that hard disk or secondary storage that you create, you can have a similar kind of read-only memory from which you are just reading. You're not writing anything while running the program. So any application that runs. So whenever we are running an application, the secondary storage serves as the read-only memory until we are writing it back into it. So while running any logic, if we are using any memory. So read-only memory is not a like memory. It is a term given to a particular kind of memory, right? So any memory that we are using in a read-only mode while running our application is known as a read-only memory. Understood? Okay. Now coming back to our question, so we use RAM. Why don't we use cache and register while running? We use cache and register. We use less of them because there is very less amount of it is available, right? So my Chrome is right now consuming 1.5 GB of RAM. Now cache is only present 2 MB in my system. So it cannot even like it wants to store things in cache, it cannot. So it stores only very crucial information. Every application has a very small amount of access to the cache. Okay, very small amount of access is given to the applications by the operating system to use cache. They cannot use a lot of cache memory because that is very limited and it should be shared within all the applications and all those things. Okay, understood? Okay. Now coming to this part, so we use RAM to run our code. Okay, so whenever we run our program, we use RAM and we ask the RAM that we want to run our code, give us some space. We might need it to create array. We might need it to store some variables. We might need it to like store any data information that we have of any particular type. Now the RAM gives us space and it is in different parts. Okay. So the space that we get from RAM is divided into 3 parts in Java. Okay. So the first part of the space is stack. Okay. This part of the space is stack. This part of the space is heap. And then there is a small part which is within the heap. So this part is a part of the heap itself, which we call as a string constant pool. Okay. So, okay. So we have one part which is stack. We have one part which is heap. And we have the third part which is known as string constant pool. Okay. Now, what is these 3 parts and how Java has created? So this one is the easiest one. Okay. So anything that you create using string type goes into this string constant pool. Okay. So if you just write a string s and you store the value hello, this hello will be stored in this string constant pool. So what Java would do, this will tell the string constant pool, give me a space. How much amount of space? Right. So memory is in MBs, GBs, KBs, right? So it will ask how much amount of space. So what is the amount of space we need to store this string? So this is 5 characters. Each character is 2 bytes. So 5 into 2, 10 bytes. So Java will ask, give me 10 bytes from the string constant pool and I want to store the word hello. So it will take 10 bytes, store the word hello in it. Now, whenever I'll refer S, it is going to read from this memory and give me the value that it has stored in there. Okay. I cannot change strings, like I cannot update the size of these strings. I cannot add new characters at the end. I cannot add new characters at the start. Okay. Now, whenever you do, so you'll say, sir, we can do string concatenation. Does it not like when if I write S plus A, B, C, is it not adding new characters at the end? Actually, it is not. Okay. So when you do this, it is actually not adding new characters at the end. What it is actually doing is it is telling Java create a new string. Okay, which is of size hello plus 3. So 5 plus 3, total 8 characters. 8 into 2, 16 bytes. Create a new string of 16 bytes in memory. Okay. Forget about the older space that you gave me. Forget about this. Forget about the older space. If I am storing it in this, right? If I write s equals to this, right? If I don't write, then this would also be there, right? If I overwrite s, then what it would tell is forget about the previous space, create a new space and store all these characters hello ABC and put it as s. Now I'll explain you about in very detail what is the difference that this causes. This single thing, right? That creation of new string and storing the values, how big of a problem this is. when we'll like understand about time, space, complexity, and strings. Okay, for now, you just need to know that whenever you do string concatenation, a new string is created, a new amount of memory is given to you, and you store the new string. You forget about the previous string in case you are overwriting it. In case you are storing it in some other variable s2, then you have both the strings, right? So s1, s would refer to this string, hello, and the s2 would refer to that string. So we don't have eraser. Where did the eraser go? Okay. Okay, so we have a 16 bytes. In case we are getting it as s2, so it will be creating a new string, and in case we are using the same string, so it will delete the previous one and create a new string. Understood how memory works for string? So when you create string, a memory is given to you where you store this, which is exactly size of the number of characters matching. In case you concatenate it, you change it, the new string is created, and you get now the variable will refer to the new memory. So whenever you call variables, okay, I got it. Okay, this is I got the. So where did this submenu come from? I don't know. Acha, when you click on this pen, okay. I guess earlier it used to be over here, and then they have moved it to here. That's interesting. Okay. Okay, understood this part of string. Okay. Now, next part. What is stack and heap? So the normal variables that you create, right? So the variables for which you know the values, for which you know the size during the compile time of the program. So when you compile the program, right? So there are two steps: compilation, converting like things from English to binary. This was the compilation stage, right? And then we had a second phase where we ran from binary to we got this binary and runs, right? The binary code actually runs, the machine runs this binary code and gives us the result, right? So there were two steps to of this logic. So first one was and this we told as compilation, and this we called as execution of the program, right? Execution or running of the program. Okay, just a second. So all the spaces that we come to know about during the compile time of the program. Okay, sorry. So all the things that we come to know about during the compile time of the program, all the spaces. So for example, when you create a variable, integer variable A. Okay. So when you create an integer variable A, it simply means that you want 4 bytes of memory. When you create a character variable A, character variable CH, it means that you want 2 bytes of memory. So it directly tells how many bytes of memory you need. So all these variable creations for which you know the size of this before, and this goes to the stack. So these kind of things are stored in the stack of the memory, right? Stack part of the memory. So if you create an int A equals to int 5, so this is stored in the stack, right? A variable having a space 4 bytes storing the value 5. You create a ch variable, it gets the value in the stack, which is storing a character A. Okay. So for all the things that you know the size during the compile time goes into the stack part of the memory. For example, your integer variables, character variables, float, boolean, double, all these things. Okay. Now only here there is one special case, which is array, which goes into the heap section even though you know the size. Okay. So for example, this array, I can know the size, that this size of array is this is 6 integers. I can know the size during the compile time. So I can give it okay, this is 6 into 4, 24 bytes. But still, this array is a special case which goes into the heap part of the memory. Okay. So whenever you create an array, it takes the space from the heap part of the memory and store this array into the heap section. Okay. Why it does it? Because there can be arrays for which you cannot know the size until you run the code actually. Okay. How can those array be created? Let me give you one example. Okay. So you can create an array like this, int a square brackets, and you can give int a is equals to new int. Okay. And you can tell what is the size of this array. So you can tell 10, that I want to create an array of 10 size. Okay. And let's say just if you print this array, so you print it and you find out the size. Okay. So let's say you find out the size in 10 is equals to a dot length. Okay. So find out the size, you run a loop that prints this array. If I run this, by default, the array's values are going to be 0. In case you don't put any values into array, it is going to be 0. Okay. So you see 10 zeros over here. There is no value that is present in the array. By default, all the array values are 0. Okay. Now, if you want to put, you can put values. You want to get the user input, you can scan int and you can put it into array, right? That you can do. But there can be way where you cannot guess any way the size of array until you run the program. So if I take this input as the size from the user using st.nextInt, and I just pass n. Okay, what I've done, I've taken a user input of size n, which is telling me the size of array. I create an array of size n. Now, no matter Java compiles this code, converts it into binary, Java cannot know what is the size of array until it runs the code and user gives the input. So when I run this code and the user tells me, okay, this is the size of array, then only I can know the size of array. Now, when I give input as 5 and press enter, then only Java knows that this is. And now we are in the running state. Code is actually running right at this point. So here, the Java cannot guess in any way in during the compilation phase that what is the size of this array going to be. So all such thing which is uncertain, for example, array, the best case, right? Array is one of the fundamental data structure from which we have built a lot of things. Okay. So array is stored over here. Okay, which we store over here, which goes into the heap section. So in simple words, I'll say ki all the sizes that you can know in the compile time apart from array, that you can create array which you know the compile time, but it will go to the heap. So compile time things, the sizes that you know in the compile time goes to the stack. There are other things as well, just from variables. There are functions that is pushed into stack as well. But apart from that, the variables that you know in the runtime, like array, goes into the heap section. So how it is decided, this Java does, right? So Java, like it is like a general, so Java, let's say, for example, when I'm running the code, Java will ask the RAM, hey, can you give me some space? So RAM will tell, okay, let me give you some space. How much space do you want? So Java will say, okay, I want 100 MB, give me 100 MB for now. If I later want more, I'll ask you more. Okay. So out of 100 MB, it will like know the size of the stack, how much amount of stack size it knows. Advantage. Okay. It can even expand this later for function calls, that is different. Let's assume ki chalo, stack ke liye it got some space. It put the remaining amount of space in heap and then it reserved some space for the string constant pool. So it would like first thing is, let's say if one of the space exhausts, let's say we exhaust the heap. So it will see if it can get some part of the stack and put it into the heap. It will try to do that. Okay. If it does, okay, and let's say somehow the stack also got exhausted, and so it will check it can you use the some part of string constant pool. It can. If not, if all of them is exhausted, then it will ask the machine computer that, hey computer, you gave me 100 MB, but now my code is taking more space. Can you give me a more 100 MB or something like that? Okay, it will get more 100 MB. It will use it in the heap or add it to the stack in case whichever is overflowed. Take or a string constant pool or something. Okay, so that is completely how Java deals it. I'm just giving you a hypothetical situation how it might be dealing. Okay, you don't have to worry about how it gets. It gets some space. It creates 3 different parts of it, which we are using. Okay. String constant pool part of heap. Yes, string constant pool is a part of heap. If we decide before it is to go into the stacks, if it declare before it is go into stack. So like if we declare before, for example, here, no, it won't go. Arrays always goes to the heap. So it's even if that's what I'm telling, even if you declare array like this, it will be there in the heap. Yeah, it is in the section. There is a question which is asking to take inputs of the array without taking. Are you talking about the odd number question? Where there is no size mentioned and you have to take inputs until the odd number is hit. Right? So that is doable. That can be solved. You will solve that. Don't worry. Okay, understood this one. I'll go it little bit slow. There is a lot of conceptual things. Okay. So see, now we understood that there are basically three parts of memory: stack, heap, string constant pool. String constant pool is a part of heap. Now, what's the reason why? This is one common question. Why is string constant pool part of heap? Not why is it not part of stack? Okay. Acha. Or tell me one thing: is this a compile time or a runtime operation? Is this a compile time or a runtime operation? Will Java know the result of this during the compilation, or it will know only the result when it runs the code? So S value might be coming from user input as well. String might be a user input S, right? We are adding a string to the user input or something, doing something on a variable. So this is a runtime code, right? So a runtime code, and we are storing it a variable S2. So can we know the size of S2 beforehand? Anyway, no, we cannot have any idea of what the size of S2 going to be if we don't know the size of S, right? So that's why this S2 can only be stored in the runtime part of the memory. What is that? Heap. So that's why string constant pool is a part of heap, not of stack. Okay. String is a special data type. String is little bit special, right? I'm from starting it, I'm telling, right? String is special. String has a lot of additional things that all the other data types that we know, like integer, float, boolean, character, they don't have. String is special in that scenario, right? String is special in that case. So that's why they have a separate space in the memory, right? Can we use user taken? Then what? Int, even int can be user taken. So int can be user taken, but the size is fixed, right? Size to 4 byte hoga, right? Even if we take integer as user input, right? If we take int a is equals to se dot next int, so we don't know the value of this, but we know that whatever value user gives, that can be at max 4 bytes, right? So that's why, there was one question that you asked, right? Sir, if I store 5 or 500 or 5,000 or 50,000, is the size of integer going to change? Does it vary? Actually, it doesn't. Why it doesn't vary? Because Java reserves 4 byte in the starting itself without even knowing what value you're storing. Right? So it reserves 4 byte for this integer variable. Now you store 5, you store 0, you store 500, you store 50,000, you store 5 lakh. Doesn't matter, the size is going to be 4 bytes. Right? Okay, the size we know comes in the stack section. The size we know comes in the stack section except array, right? Except array, you might even know the size in compile time. For example, this is one situation, but this would still go to heap. So arrays always go to heap. Apart from that, all the things that we know, so will go to stack. Okay. Heap part, okay. Heap is one part of the memory which stores, which we can use while running the code. So heap is a runtime memory. So things that we create during runtime. So we can create a array during runtime, right? So we saw how we can create an array during runtime. So we can create an array for which the size can be given by user. So that is a complete array that is created by runtime. We cannot even know the size of this array. So that will go to heap. Are there any other things? Yes, there are objects that we can store during runtime. There are string builders. There, like, so all of them are part of objects. So there are only two different types: arrays and objects. All the other things that you have heard, like array list, maps, string builder, everything is nothing but object type. Okay. For example, when stack is full, first priority it searches for memory in heap or pool and takes the memory from the computer. No, firstly it will look for within itself reallocation. Ideally, that would be the scenario, right? And once that within itself there is no possible way to reallocate the memory between stack, heap, or string pool, then it will look for the outside. Okay. I guess Java would have designed it for most likely in this way, right? This would be there in some other languages as well. So this should be there in this way instead. Okay, it is most likely in this way. It won't be like so, because if it has reserved 50 MB for heap and we are not using it, so that is a wastage of memory, right? So it would often, like, no application would try to waste your memory, right? So memory, while it has it, all application wants to be extremely efficient and they don't want to waste the memory. Understood? If array int is size 4, then memory will be 4 into 4. Yes, array integer is size 4, then memory will be 4. Okay, understood? Okay. Now got some idea of it. Okay, some idea of memory, right? Achha, now let me give you a little bit more idea on it. Okay. Achha. So I told you that earlier when we used to write A, B, C, something like that. Just a second. Okay. See. So earlier when we were writing variable and we are writing system.out.println something, we used to see the like value that is stored in that variable, right? Right. Non-primitive, yes, non-primitive data types, you can say in general it uses heap. Primitive data types uses stack. Only one difference is there is the string, which is string is a reference type, right? So that is a non-primitive, so that also uses, that has a different pool altogether. It is not in the stack heap, it has a separate pool. Okay, understood? Okay, thanks Adnan. Okay, now the last part, this is very interesting. This is even interesting than what we learned till now. Okay, and this is the most fundamental concept in array. So when you create a variable A and you print it, so what it prints, it actually used to print the value, right? But now here, when you print array, you see some random things. Now, is this some random value that it is printing, or does it actually mean something? So it is actually the address of the memory that we are seeing, right? So what is this address of memory, and like what is this new thing that I'm talking about? So see, okay, let's say we have like our houses in some places. So how do you order things on Amazon? When you place an order on Amazon or Flipkart, you put that this is the address of your home, right? You put the address, and that's how the delivery courier person, it reaches from Bangalore or Hyderabad, some place, and it searches for your location using your pin code, and within that it looks for your street name, then looks for your house number, and then delivers it there, right? So on. So there is a so it follows the address. Same way, every place in the memory has an address associated with it. So every place, even a single bit of information that you store in memory has a valid address to associated with it. So for example, let's say how our memory looks like. So I'll give you some idea about memory. So let's say this is our memory chart. Okay. So let's say ultimately it is, what is this? These are very small amounts of memory, very, very small. Okay. Achha. So each cell in this memory stores a single bit of information that is either a single 0 or a single 1. Okay. This is how your memory actually looks like, where every part of this memory stores a single 0 and single 1. Every bit of memory has a valid address to it. So if you want to access any particular bit of information, you just need to tell that this is the address of which I want to access the information. It will give you whether in that address it is stored in a 0 or it is stored a single 1. Okay. Do we deal it in such granular level? No. Java does it. Java does little bit of this, right? Little bit of passing Java does. So it doesn't ask us to deal with every bit. It can tell it that I want to interact with this particular byte of memory, this particular part of memory. Let's say if when I write A of 1, what am I telling? I'm telling it, give me that part of information that is stored in array at index 1. Now Java has written that logic of how it will go through, which are the 4 bytes. So it 4 bytes altogether is 32 bits of information. So each integer is 4 bytes, assuming this array is of integer type. Okay. So if this is a 4-byte information, so 4-byte information will be 32 bits. So there will be 32 blocks of memory that is actually storing it. Now that part Java deals how it gets the address from those 32 bits, converts it into the number, gives you. We agreed, right? This is what Java's role is, and that's where we won't be interacting with the bits of information. We agreed that we'll write English. Java will take care of the rest of the logic where it will convert binary to get the information in binary to us in English. Okay. So that Java does for us. Okay. Now coming back to this discussion, I'll give you a small insight on this one. So let's say this is how the memory looks like. Okay. So how many of you remember there used to be SD cards or the memory cards that we used to have like this, which we used to insert in our phone, and then our phone used to like increase the size, right? 32 bits, 64 bits, 8 bits, 64 MB, 10 MB, 64 GB, 5 GB, 8 GB, ऐसा कुछ memory cards होता है, right? 4 GB, 8 GB, something like that. Yes. Let's say this was a 8 GB, everyone knows, right? ऐसा कुछ होता था. And this is also the 16 GB memory. Achha, tell me one thing. Did you ever observe that this 16 GB memory and 8 GB memory, both of them were of same size? They did not differ in size. Even the 1 GB memory was of same size as the 16 GB. There was no difference in that, right? So how it was storing more information than the 1 GB? So like it was storing almost 16 times information. So 1 GB was storing and it used to cost us even more, right? So let's say 1 GB memory card used to cost us, let's say 200 rupees. Okay, so say 16 GB would cost us. So this is the cost of 1 GB. So 16 GB would cost us, let's say around 1200 rupees, right? So there is a very significant difference in that. Size was same. So see, so that I'll give you, I'll not go into the very detail. I'm not like teaching you electrical here, but I'll tell you about computer science way of understanding this, how you can understand it. See, there is like, I told you that in memory, there are cells which store a single bit of information, that is 0 and 1. Okay. Now, consider a 1 GB memory, how many cells it would have? So this would have less cells, right? So if one cell is storing a single 0 and 1, this would have less cells. If 16 GB stores 6 single 0 and 1s, and then there will be more cells over here. How many more cells? To be precise, 16 times more cells, right? So there were 16 times more such space, more such cells, more such blocks in the 16 GB memory as compared to the 1 GB memory. Okay. Now, in order to create, since the physical size is same, physical size to same, the physical size, right? Both the memory cards used to be of same size. So how does this vary, right? In like actually how this was varying. So actually this cells, so let's say this is the size of cell in a 1 GB memory card. This same cell will be divided further into 16 parts to store 16 bits, right? So the same cell, the same size of cell that is there in 1 GB, the same cell can store 16 bit of information in a 16 GB memory card. Now to create something even such granular, we required more precision machines. So the cost of machines is more higher. So the people who are purchasing this machine, they would be selling the memory card at a higher cost as compared to the 1 GB memory card, right? So 1 GB's memory card, to create them, the precision of machines that's required is lesser. So that this was cheaper, right? And to create this one, the precision of machines was required are very high. So this was costly, right? So since the investment to create such thing is more, so obviously the end cost would be more for the product, right? Understood this? So basically, if you keep on dividing it even further, you might even get a 32 GB, 64 GB, 128 GB with of the same size memory. Understood? Okay. Same as multi-core, single threading. That is like more of operating system way of telling it. I told you in a simple name in terms of how you can understand this, right? As a simple, like if you try to explain the same thing to another person, let's say who doesn't know computer science. So how will you explain why, if you get a simple question, like if the size of both the things are same, why I'm paying 200 rupees for the 1 GB and 1200 rupees for the 16 GB, right? So this is the actual reason. Okay, now coming back to this. So every bit, right, even it like this is a very small space, or even if it is a very large space, so that is having some address. Now, when you create an array, I'll take not more than 5 minutes to complete this. Okay, so you'll get the complete picture of the memory. So when you create an array, what happens is you are asking some memories. Okay, so while creating this array in the heap, you know the size, right? While creation, you know, while running, while compiling the code, you might not know, while doing, initially converting into binary, all those steps you might not know, but while you are actually running the code, that time you will 100% know what is the size of this array that you're going to get, right? Because that's how you'll create it in the actual memory, right? So we created an array, we gave it a name A, and we got, let's say we got 5, 6 spaces. So 1, 0, 1, 2, 3, 4, 5. Okay. So what this a variable stores? So when I created a as a normal variable, it was storing this value 50, 20, whatever I stored in this variable. When I print a, it prints this value. But when I'm printing a, I am seeing some random value like this that is getting printed. What I'm telling is this is the address of this first block of memory of the array. This, what is this? This is the address of, so what does a store? A stores the address of first block of memory of array. Okay, this stores the address of first block of memory. So why it starts with indexing 0? So when you write a of 0, it means the address that we already have. What is the address? This address, and they are in a continuous fashion. So if you add some offset, you will get the address of this part. Okay, so it means the base address plus 0. There is no additional offset. So give me the value that is present at the base address, that is a of 0. Okay, when I write a of 1, it means that add 1, exact 1 byte, 1 bit, or what is this 1? So it means one quantity of the size of this array. So what is the size of each element of this array? So this is int. So add 4 bytes. Okay, so 1 into 4 bytes. So this is whatever is a plus 4 bytes of memory, whatever is the address of it. We can do addition and we can get the address of that. Address addition works. So it's similar, like let's say there is house S on the street. Okay, there is houses on the street, and this house is numbered as 1, this house is numbered as 2, this house is numbered as 3, this house is numbered as 4, this house is numbered as 5. So if I tell you to find out the 5th house, and you're on the first house, so you'll say, okay, I'll add 4 to I get to the 5th house. So I'll skip 4 houses and I'll be on the 5th house. Okay, even though these houses does not have numbering, you'll get to know that if I skip 4 houses, I'll be on the 5th house. Right, the same way it knows that 4 bytes, if it adds 4 bytes to the current address, it will get the address of the a of 1. What is a of 2? So it is nothing but the base address plus 2 into that size of each address. So a plus 8 bytes. So it will give me the address of a of 2. Okay, understood? So this is the entire concept of memory in case of array. So whenever you create array, it asks some memory from the heap section, creates the array in that heap section of the memory. You have that address of the initial memory that you got stored in a variable. Okay, and whenever you access a of 0, a of 1, a of 2, you are just adding some offset to that base address, and you're trying to get that address of that particular location. This happens in a this happens very quickly. This is very fast. So you get the address in very just like accessing any other variable for which you know the address. As if you store b and 100, you access a, b, right? And using the same amount of time, you can access a of 1, a of 2, a of 3, because this operation does not take any time at all. Okay, understood? Clear? It is kind of same concept in OS, sir, where we block where stores the address of each block. Right. So see, actually the memory is very granular, right? It stores bit, but to the upper layers we see bytes of information, so we think it in terms of bytes. Okay, so here when we are accessing a of 0, a of 1, I'm telling that skip the first 4 bytes, go to the next 4 bytes. So this looks like a single step of instruction that I'm giving to it, right? But think of what Java is doing behind, right? So when I write a of 1, what Java does? So Java doesn't know what is the address of a of 1. So Java knows what is the address that is stored in a. What I'm telling is find out the address of the first element. So like a second element which is stored at index 1. So it will try to find out 1 into whatever is the size 4. Then it will add the address, it'll find out the new address, and then it will access that address. So it does so much work behind this. It is very fast. It does it like accessing any other variable, but this is the amount of work that Java does behind it. So yes, now there is one. This is a reference. Now, what is the difference between an actual address and a reference? That I'll cover tomorrow. I guess this much be too much for today. So I'll cover the difference between the address versus reference. Okay. Or in case you know what is the difference between physical and logical address. So this is that, physical versus logical address. Okay, so these are the few concepts that you need to know, which will help you understand array better. And trust me, if you understand this memory concept, so when I will teach you array list, when I'll teach you a linked list, when I'll teach you about stack, when I'll teach you about queue, you will right away be able to get, okay, why these data structures exist, what is the difference between them fundamentally. See, anyone, if you Google up, anyone will come and tell you that this is queue. Okay, you push things into this and you get things out of it. This is stack, you put things on the top of one another. This is linked list. But why do we have so many things, right? Reason kya hai? Memory mein how they differ, right? How they are storing things actually in the memory. That is the fundamental concept, right? If you understand this, no matter tomorrow you want to create your own data structure, there is a necessity of creating your own data structure, you'll do it. So for example, I'll give you my day-to-day job, right? We involve using data structures that are created by Microsoft. So they have created their own data structures that's not even there available outside for anyone else to use, right? So how can you understand such data structure which does not even exist, right? I have never heard that those data structures name before joining Microsoft. There is no documentation, there is no videos you can find out online for that, right? So what's the best way to understand them? If you understand memory, you can understand such kind of things that you might see in your development journey later on, right? So you'll be understanding, okay, this is how it works. This is how it is similar to array. This is how similar to array list, or this is how it's similar to something that you have done. It might be similar to something, right? Uske saath to similar ho. And fundamentally, we have only one data structure that's there, which is like, what is meant by creating your own data structure? So like array, right? So array is there already, right? So array is like storing a list of numbers. There is some other requirement. Let's say you want to store a numbers in a particular way. Now array cannot store, right? So array cannot store in a particular way. You can create array, store it. Now for that, we need to create our own data structure. This is one of the very fundamental data structure that's there in every programming language, right? How many persons to create a data structure? There is a complete team which is there in Redmond which creates it. Like think of an array that can store data values of multiple types. That can be a data structure that we want to create, right? So right now the array that is given to us has the capability of storing the data values of a single type. We cannot store multiple types. But what if we want? So we can create if we know how memory works, how things work, right? That would give us a lot of control of this. Okay, understood the memory part of it that Microsoft have. So Microsoft have even complicated than that, right? I myself try to go through that paper, like documentations that they have written, and that's like way complicated, right? Trust me, it's so complicated. Even to understand one page of it, it takes like 2-3 days to understand how they have built it. So see, because if it was so simple to create and so simple to use, it might exist, right? Because someone has created. Because since it is so difficult, they created. Right? So you might see things like that. Get to work on, and interestingly, I am part of team that does this, right? So I've seen even other teams doing it. So if you go to see such challenging problems, this concepts will help you understand those things there. Okay. Okay, now got some idea of memory. Don't worry, we'll build on this. This might look like a lot of theory, lot of overwhelming information for a single day, but we'll break this into chunks. We'll use arrays and that you will get used to it. To make our language first. No. We can use the existing languages to create our data structures. Okay. So we'll see. Luckily, array list is also there in this particular array list is also there in this particular module, and I love that part of this Pioneer batch, right? Where the array list is also there. So we can continue on the array list, and there you'll see the usage of array in this memory concept. Once I explain the memory concept, it'll be like it will be so easy for you to understand array list as compared to any other thing. Why array is immutable? And okay, now one last question, right? Why is array immutable? Okay, so why is not array allowing us to add or remove numbers from the start or the end? Why array doesn't allow to do this? Just look at here, right? So how memory works? So memory works in this way, right? So if you want to use memory, you have to tell that this is the amount of memory I need, right? So if you don't tell that how much amount of memory you need, Java cannot give you that. No machine can give you that memory. We cannot use it. That so for that, if let's say I asked for Java initially that give me 10 bytes, or we asked Java give me an array of size 5. So it will ask that many size. So if I ask of size 5, it will ask 5 into 4, whatever is the size, 20 bytes. Like if it was of integer type, so it will ask 20 bytes from memory and it will create an array of 20 bytes, taking that size. Now, the next size might be given to some other variable. The beforehand size might be given to some other variable, right? Array list does it without asking, right? Now, that's the interesting part, right? If you want to understand, try to Google up. Array list does not violate this. Okay. It's interesting how array list does it. So array list actually creates a new array every time it exceeds a given size. Okay. But now the question is how it does it in so small amount of time. So that I'll explain you when we learn about array list, which is our next topic. Okay. I'll explain you how it does, but there is no possible way to skip this array. So we have to specify the size to the machine. Machine cannot give a space without knowing the size. So if we can tell the size, then only it will give the space. And we cannot increase that to left to right. That space is fixed. Okay. The next array will also have some unused space, but you can keep on adding numbers to the array list. Like you create initial array list, you can add 10 to the power 6 numbers. So does it actually take 10 to the power 6 size initially, and then what if you add only 5 numbers? Then so much space you are wasting, right? You are asking so much of space and then you are not using it. Java is taking. So Java would have thought something smarter, right? Now, what is that smartness that Java did? Right, so the same data structure is present in C++ with the name vector. The same thing is present in JavaScript with the name list, and same is there in every other language, and they use the same concept. Okay, of space. Okay, so the space concept is same in all the languages, but in regular arrays we don't mention column size, right? How does it take without asking? So no, in Java you need to mention the column size as well. Okay, just that in case of C++, when you are passing that to the parameter, then you can skip the column size. You just need to mention the row sizes. So you need to mention the column size. You can skip the row size. But here you cannot create a 2-dimensional array without mentioning the row and column size. You need to do that both. Okay. Achha, in column, this one you are telling. Then this one. Okay. So it will be creating with empty spaces. So it is basically like writing empty array, right? So this won't create any space actually. So this is empty array, right? Won't be taking any space. It is not mutable. So you cannot put any values in it. So this is like creating this array of length 0, right? So I guess this one. So this is like creating this array of length 0. It does not have anything. You cannot add values to it, right? You cannot push values. You cannot access it. So see, okay, let me do one thing. So system.out.println e of 0, 0. If I run this, see, this is not there, right? This is returning null. There is no such value, right? There is a of 0, 0 does not exist on this. This is null point exception, right? This is no value that is existing. Okay. So see, even if you're creating, it is not actually creating anything, right? It is not having any memory in the array. It is just creating like you know that you have array of 10 size. You might do this a of now I'll tell you in 2D arrays how this thing works, right? So for example, if you write a of 0 is equals to new int and you do this, then it will create a so this works. So now if you run this, it will give you a 0. So this is different. The array was actually not created over here. Array got created over here, right? So this is not actually creating any array. This is not actually doing anything. This is just telling you that this just remembers that you have given the size of 10, but it is never creating anything in memory. Memory mein abhi tak kuch nahi hua tha until we did this operation. Okay. Now, what is this new keyword? So new is the keyword that is actually giving us that space. So the space that I'm talking about, we are asking the machine the space. This new keyword tells that give me some space. So new keyword is this keyword that we use to ask the compiler, give me some space during the runtime of the program. So if you want any space during runtime, that will be given by the new keyword. Okay, so this will be used whenever you require space during runtime. That will which will give you space from the heap section. Or did someone? Oh, my access was invoked to this board. Okay, did someone change things on this board? Please don't change it. I guess I shared the editable link. Sorry. No, this is interesting. Please don't do it. I wrote it so much of words, it will get lost for others, right? So if you have changed the, someone has changed the permissions, please revert it back, right? Otherwise, it would be difficult for others to access and for me to access as well, right? Okay, now it's there. Okay, thank you. Okay, see, so right. So now it's like okay. So now what I was telling is over here. So that was actually not consuming space. Now, whenever you are using new keyword, it is asking that to give the space from the heap section, right? So that's what is happening. 2D arrays can have two different sizes, so they are actually created as 1D arrays. I'll talk about them in detail in 2D arrays while apart, how they are created. So they are actually different to 1D arrays that we know. So we just store the references of different 1D arrays. So that is no actually 2D array like matrix in memory. There are multiple 1D arrays. That's why you can create A of 0 as a single row array, right? You can print A of 0, that will print the address of the that particular row. Okay. Okay, understood the concept of memory, got some idea. So okay, we'll build upon this, we'll understand a little bit more on depth. I've shared this slides, I've shared this. Let me share the functions while apart. So we today did a lot of things. Actually, we learned about memory concept, which is very important in this. So let me share the links again. So yeah, we'll start by explaining you logical. Please paste it in your groups. I'll ensure that this also gets pasted. So community, I don't know what's the problem in there. So tech team already knows, so they might be working on it, or they might be rolling out something new, I guess. Not this one, right? So I want functions. Now we are getting started. So till now we were just ramping up. We are learning the basics, but in a more concrete way, right? So till now, whatever we are learning, I guess those were more depth than whatever you learned in pre-course. Now from here on, whatever you things you learn is going to be way advanced than the things that you saw in pre-course. And these are actually things that will be helping you in your real job and in your interviews. Okay. So in your interviews, you'll get things like this. Right, memory concepts, you'll be asked how does the memory work, what is stack, what is heap, what things goes into stack, what thing goes into heap, what is A of 1 actually referencing, what is the thing that you see when you print A, which is an array, right? So is it a value, it is a random thing, is it an address? Okay, if address, then how do you get this address? What does it actually mean? So all those questions that you will get in interviews, and from here on we'll build on that. Okay. So I've pasted the links. Please anyone save this, put it in your groups. Take both the links. So both the online GDP links are different. One is for the functions, one another is this. Is there a name of, is this the name of OS concepts? No, OS concepts are different. Operating systems basically is a, so operating system is more of like entire how system, your computer works, beginning from your memory to your CPU to your like processing that happens in RAM, hard disk, how the things load, how an application runs, so I told you, right? Application runs on RAM, it is stored in hard disk. How this thing happens, right? How it optimizes it, how it improves it, what are the like how it gives you space, how it reads things, how you when you read when you play a file, what happens when you open a file, how that file is shown to you. So all those things are part of operating systems. Okay. So that is a more depth. I'm giving you a slight idea now. That is like very easy. That concepts are very easy to understand. Okay, because that is very practical concepts. You can easily understand. There is no such very complicated thing in operating system. Functions is also called as methods, right? Yes, yes. So in Java, like it is, functions and methods are same because function cannot exist outside class. If you are talking about non-Java, right? So non-Java function methods refer to things which are part of class. Method refer to functions which are part of class. Generally, we call methods which are part of class as functions which are part of class as methods. In Java, all functions are by default part of classes, so they are known as methods. So in Java, it is same. But in programming language, let's say C++, where you can create methods without, where you can create functions without having a class, right? So those are known as general functions, right? We refer them as methods, right, interchangeably terms, but method is the correct definition of method is a function which is a part of class. Okay. Understood? Clear? Yes, no? Okay, so I have pasted the links. Please anyone copy it, put it in our WhatsApp group. I hope like this was more interesting than all the sessions that we had till now. And going forward, we'll have such more interesting discussions where we'll learn a lot more about this. Okay. Thank you, everyone. Any doubts? Anything that you want to ask? Anyone? Yes, you can unmute. You can ask. If you have doubts, questions. No. Thank you, everyone. See you all tomorrow. Good night. Solve all the functions assignment. Diamond, I'll solve tomorrow. Okay, diamond pattern I'll solve tomorrow. Functions assignment will solve tomorrow. I'll explain one binary to decimal wala question. We'll start with then arrays question. Okay, so array I gave you the basic concept. You understood and now. Internships without career page off campus. Internshala, Angel List, High Risk. Then there is Cut Short. These are few sites where you can look for them. Right. LinkedIn is one best where right now LinkedIn is like very good. Microsoft is like just hires through it. At good companies, they would generally either place it their openings at LinkedIn or you have to go through their career pages. They generally don't list it at different places, and specifically internship, they list it only on its career pages. So you just need to follow their career pages, visit them regularly, keep track from there. Right, that's the only way. Right, I know it's a very hassle of process, but there is. You might, if you keep on looking it, you might see it in your Google feed, all the news related to it. So there are news agencies will keep on posting about them if there is openings at these companies. There are too many, yes, that is anyways going to be. So I even saw like job postings where there was one opening and there were more than 25,000 applications that were applied. So like really impossible to go through them, right? But referrals help, right? So if you reach out to anyone on these companies, they will be happy to refer you, right? So yeah, if you need referrals at Microsoft, ping me, right? If you feel like you can crack it, I'll be happy to refer. Okay. Thank you, everyone. Some tips for referrals. Like try to approach to multiple people, right? Never try to stick to like approach someone, he might not even see the message. So try to be formal, right? Just don't try to write, hello, this, I want a referral, can you give me? No, just give you some idea that I have worked on this, I have built this project, this is my resume. I have done like this is my experience. I've solved so many questions on lead code. I've done so many. I've done a training with AccuJob where I learned about DSA, front end, back end concepts. Right. This is like few of my projects which you can look at. Right. These are the something that I've built. Give you some idea about you, and then tell me I'm I came across this opening at your company. Where can you refer me? So if you write like put effort in that message, generally people appreciate the effort, right? And they would definitely respond to you. They will definitely try to refer you, right? But yeah, if you just write, hey, hello, can you refer me? Most likely someone might not even, right? So yeah, but if you write message, that will impact. Should I approach my problem building still some questions take more than 1 hour to solve. That's why I solve 4 my questions a day. So Ajit, you can stick to this rule, like you can try to approach a question for 40 minutes, 30 minutes, keep that time like 30, 40 minutes. 45 minutes if it, so keep it like 30 minutes for easy, 45 to 1 hour for medium, and 1.5 hours for hard. If it is taking beyond that, right, then try to take to the help from the hints that they're in the platform. Try to ask in the chat what can be the ways to solve this. Try to look for Google up, right? Try to understand it, not write or copy paste the code from there. Understand it, solve it yourself. Do this repeatedly, you'll get solutions of you one. You might need to watch videos of something and understand more of it. right? Or ask it in the class, or we can discuss it, right? So that we can do. And this is how gradually your problem solving skills will improve, right? How much in DSA is required for max up internship? So the things that you'll learn here till module 3. So that's yeah, that's what it will be required. So till DP, dynamic programming, graph, backtracking, all these things they ask, and they start from there. The first question have dynamic programming, stacks, linked with these kind of questions they ask. Arrays, very lucky enough if you get an array question. DP is there in DS, it is there in module 3, I guess. Module 4 it's there. I guess 3 or 4 mein hoga. 3 mein, I guess 3 or 4 mein. I guess they have switched it, right? Little bit of shuffling is there in between modules, so you can keep track of that. Okay. So don't worry, right? You'll get the update of the entire module before the module starts. So in this module, next module, I guess linked list tag QA and oops concept hai, which was earlier there. And so the third module will be this part. Okay. So might be if it's not in 3, then it's definitely in the 4th module, right? So there might be things like trees. Trees is there in 3rd module. So trees is important. Then you have heaps in 3rd module. Trees, heaps, or DP hai, I guess. Tree, heap, DP, and backtracking. 4 things is there. 4 weeks for 3rd module. I guess that's there. Okay, you will check that, right? There, that we can see. Okay. No, solving assignment constraints are not sufficient, right? That's there just to this is like at least which you should solve to we can say you that you understood somewhat of array, right? But to build concept, but to understand better, assignments are not. That's why there is a gym section, right? That's why I always push you to solve gym. That's why I take up the doubts from the gym section. That's why we have like separate doubt sessions which are there for gym section, right? Assignment questions I solve every day in class. Gym sections questions are thing which will improve your skills. Assignment mein there is going to be one question of each type, which cannot improve your like problem solving skill to a particular extent. That can give you idea of a topic. You can understand arrays, you can understand how it works, you can solve a few problems, but to develop a command over it, you can need to solve more gym questions. Or yes, 4 months would be fine. 4 months learning of this, building at least 1-2 projects by that time. That would be better, right? Should we solve? How many gym questions should we solve daily? Sir, say keep a target of solving at least 10 questions per day, right? Now you know concepts, now arrays, and I'll give you more concepts, and then you'll be exposed to a lot more things. Okay. DP is there in 8th module. I guess there might be some reshuffling that they have moved it to 8th module. So I might discuss it with your batch manager to pick it up if you want. But I guess ideally, if they have structured it, there might be some logical reasoning that they have put forward, right? You can get more time to practice your initial set of DSA, build some projects, and then go to advanced DSA, right? For sometimes it takes 1-2 hours also even solving errors. So for now it's fine, right? It will improve. Your time duration will gradually decrease. It will improve, and then you can like solve more questions in a smaller time frame. If stick to create your 1 hour for easy question, right? If it takes more than that, then see the solution. Try to look for some hints, something. Try to think of solution, right? Try to if nothing strikes, then try to think for hints. Seek for the chat support. Seek for online help support that is there, right? Yeah, that will improve. Okay. Thank you, everyone. Solve more questions. I'll say. Okay, even if it's taking time, you are hustling. That's fine, right? Every engineer goes through it, right? That's our day-to-day job. If I'll tell you how frustrating it is for my day-to-day job, right? It looks so easy, right? Sitting in a laptop doing code. And you all know code doesn't work that way, right? You have millions of lines of code. There is some issue, some error, someone has reported. You have to figure that error out, why it is coming. You have to solve it, right? So many things. Yes, 10 questions daily at least. So if you keep target of 10 questions daily, a month you'll be 300, right? By the time you complete your course, 6 months, you will be 1800 questions. That's more than enough to solve clear any company rounds. Okay, quality questions, right? So try to keep that target. You may reach, if you reach 1800, reach your goal, very fine. If you, let's say, if trying to reach 1800, even if you reach 1500 or 1000, you're very, very, very good. Okay. And if you reach even 600, 700, so it will be a combination, right? It can never be 10 easy questions or 10 difficult. It will be a combination. So right now in array, you'll see there are 2 medium questions as well that's there in arrays assignments. There's array subtraction, array addition. There is second largest number building. So there are 4 medium questions right now that you see in array assignment. So that will be a combination. Then you will see harder questions as well going forward. Okay. Hello, arrays assignment. This assignment specifically on the array that we have right now is very interesting to discuss. This would take like around 2 days to complete this discussion itself. This single assignment. That each question will take 2 hours, 1 hour, at least 1 hour to discuss, complete it. Assignment also has 15. Yes, so solve assignments priority. Solve assignment. Once it's done, go to gym. Don't, if you have no assignment questions, go to gym. Right? Don't think right assignment is done, will we are done, right? Right. After the class talks are so much fun to know about real life. Yes, real life engineering is like patience-full job, right? So, yeah, you're learning. So I'm just trying to teach you how to be patientful enough to solve these questions in your real life, right? Will you discuss? Yes, I'll probably discuss all this one. So in this assignment particularly, I discuss all of the ones. I guess हाँ यहाँ पे सारे discuss हो जाएंगे. Apart from array problem 2, 4, I guess 3, all those you might be able to do apart from array operations. Addition, subtraction, second largest building. These 4 anyways I'll discuss medium level. Apart from that, like whatever doubts you get, that we'll discuss. Till now we do not have so many doubts, but here I'm sure, pretty much sure that you'll get doubts and good doubts over here. Okay, try to solve the assignments, you'll understand what I'm telling. Okay. Okay, chalo. Thank you everyone. See you all tomorrow. Bye bye. Good night. Take care.